Welcome to the, slightly advanced Python workshop. So don't be afraid. It's not going to be that I'm too loud, maybe, I'm saying. Okay, so a little quieter. All right, so welcome to the Python workshop. And so we'll work with some text analysis, some text content analysis, do some NLP tasks, basically natural language processing tasks. I'm Valdis Saulespurēns. I'm a lecturer at Riga Technical University. Also, I'm working here as a researcher at the National Library of Latvia. I've been programming for over 30 years and I've been programming in Python for over 15 years. And I've been teaching Python for 5 years, so I have some experience. Okay, so I assume everybody can hear me in the back. Everyone? Yes? All right. So I like the turnout. It's a good size, right? So I assume we have some remote people joining remotely. I don't know. You can raise your say thumbs up if you're remote and you can hear me. Okay. And so we'll be working I'll be sharing the screen, so you won't have to look at me too much, maybe look at the screen. And of course, we will be using this notebook environment, which I assume most of you are somewhat familiar. So Python-wise, everybody has used some Python, a little bit, right? Yes, maybe more, maybe less. And how about Jupyter Notebooks? Everyone, or more or less, right? Through Google Colab, possibly, right? So the only requirement for this to follow this is an internet connection, of course, which you have, and access to Google Colab. All right, I will be providing the links. But there's also some interest. I spoke to some of the students to talk a little bit about the optional local installation. So now maybe a show of hands, how many people completed the local installation? There was an option that when you received the email, there was an option to locally install Python on your own computer with notebook support. So this is not required for the course completion, but this is how I'm going to be working, and I know it is more convenient if somehow, of course, Google Colab goes away or breaks down, of course, right? So you never know. Right, so a couple of people did. Maybe I'll talk a little bit about this local installation first, some technical things, how it was done. And then we will go to the actual notebooks and start working. Okay, so I assume my screen will be shared now. So you don't have to look at me anymore, but my screen, right, in the back. Yeah, okay, so I should be seeing my on there, right? Yeah, okay, perfect. Right, so all of the materials for this workshop are at this repository. Maybe I'll put a link just in case you didn't get the email, or maybe, I don't know if it's actually in there. I'll put a link, so all the materials to this workshop are here, right? And of course, it'll be updated. A show of hands, how about GitHub? How many people use GitHub? Almost everyone. Perfect. Okay. I'm too loud? Okay. So I should maybe click share screen. Minimize zoom. Okay. All right. So I will need to see the options here. Where's my minimize zoom? View exit full screen? No? Yeah, exit full screen. Okay, and minimize. Okay, that's much better, right? There's still a little picture, but I can still minimize that also, I suppose, right? So if there's something in the chat, I guess I won't pay attention too much to the chat right now. Maybe Harald will see if something is in chat. He'll raise his hand and say, okay, yeah, something's going on. All right. So yeah. So everything is going to be here, right? So the links to follow, again, so if you want to make your life easy, don't do anything extra, right? All the links for all the parts, right? Today we have 3 parts, right? Will be here, opening in Colab. You can open a new tab, right? New window, new tab, or just open over, right? And it will do you'll have the notebooks. We'll get to that. You can use that. Also, there were some extra notebooks to test some prerequisites. Again, obviously, in Colab, they should work because all the libraries in Google includes all the necessary libraries. And there was a little refresher for pandas, a little bit of NumPy, some syntax refresher. This is completely optional again, right? So, but now let's talk a little bit about the local install instructions, because there was some interest. These are, I don't know, I spent maybe a little bit too much time writing these instructions, again, since they're optional. But again, for those, hopefully they might prove beneficial for those who want to do it locally, right? So again, mostly Windows users or some Mac users. One Mac, I see one Mac. How many more Macs? 2 Macs. On Linux, no. No, Windows mostly. Okay, great. All right, so again, these are made for Windows, but they should be very similar for the Mac, right? And as well as for Linux, actually, right? So the first thing is to check if you have Git. Git, of course, is code repository, is revision system. Who made Git? Who knows? Who is inventor of Git? Do you know guy Linus? Linus Torvalds? Yes. So yeah, the story goes about 2004. Of course, he's developer of Linux kernel, right? His revision system, they changed some licensing on him, maybe, and it is not a question of money, but it's more a question of freedom. So he took months off from his Linux work and he made Git, right? So, and I understand Git in English actually means like an annoying person or like a little bit of, yes. So he has a personality, right? And so that was kind of a joke on himself, right? But yeah, so Git is, of course, by due of his technical prowess, but also, you know, of course, it became the most popular these days. There were some other alternatives, and there still are, actually. But popularity-wise, there's no contest. It has won. And I'd say it's not a simple system to use, but the basics everybody can use. So the idea is that there is a bookkeeping for your code or for data. Anything, it's great for anything dealing with textual information, right? Because it keeps the track of changes. It's not so good, and it's actually not really meant for binary information, for like pictures, things which actually change, data changes, which are harder to track. And you can use it for it, but it's not great. But anyways, back to Git. You can check, you know, I can open up PowerShell or your favorite terminal, right, and check that you have Git, right? And I do have it. I have the newest version. But if you don't have it, it's really easy to install. It's not a small install. You can get the Windows version. If you click from a Mac, you should probably have the Mac version support, right? And you install it. It's maybe 30 megabytes, and you have your bookkeeping system. And then you have access to downloading, cloning code from any public repository or even private, if you have access, repository in the world. Mac-wise, no problems with Git? Installation works? Harald, or?
Yes, I have. I just maybe wanted to check if somebody is installing Git now.
No.
No? So
Okay, yeah, so this will be something to do after the end of this workshop, maybe for those who have not done it. So it's not so scary. You install it, then you open up your terminal, and you check that you have it, basically. And of course, terminal is command line, which is actually how computers really work underneath. Really, it's how you have the fine-grained access to your computing resources. We have these nice, pretty pictures, these graphical interfaces on top of it, but really what's happening underneath, we have the command line is going underneath, really. So it's good to know a little bit also about command line in general. If you're working with textual data, it'll help you, you know, your text processing tasks. Okay, so so we have Git, right? And the thing is, if you want to now, if you go here, you have options. How do you get this code, this data, these notebooks, these scripts to your computer locally, right? If you don't have Git, you could download the zip file and then unzip it, right? And you will have the project, but what's the downside to this? If you just have a zip, each time I make some changes publicly, right, you'll have to download a new zip, which might be maybe, I don't know, 30, 40 megabytes, right? It's not very efficient, right? So if you're actually using Git the way it's supposed to be, right, you only clone the repository once, and then what you do is you pull the changes, these public changes to you. So maybe only, I don't know, a couple hundred kilobytes, very small changes, you know, happen. During the workshop, maybe I'll change some files, and you'll be able to update the change without downloading the zip. So you need this address, basically, right, and then you will need to clone it into some folder, right? And my instructions were, where do you clone it, right? Right. So the key in these installation instructions was that you should check. The only mistake you can really make with Git when you're cloning something is try to clone it into a folder which is already under Git. That makes a big mess. Maybe now it gives you an error message. I don't know, maybe it just won't let you do it at all, right? But I had some students who do it, and then it's like you have two projects competing with the bookkeeping, basically, the revision, and it's a mess. So what you could do is just delete the whole folders and start over. No big deal, again. So the good news is about this Git version control is that you can, if something goes wrong, and you do have the sort of master, like the repository, you can just start over. You can clone somewhere else. It's no big deal. So yeah, and it's kind of funny about Git that it's meant to be distributed, right? Every computer gets their own repository, right? But inevitably, we end up with sites like GitHub. So it's kind of funny, like all repositories are equal, but some repositories are more equal than others, right? So because GitHub basically, it's running its own Git servers, right? It's like just a bunch of Microsoft computers. You know, Microsoft paid $8 billion for Git, right? And for GitHub, sorry. And but all it is really is just a bunch of Git repositories. So people, despite this being, distributed version control system, you still need some central hubs where people go find repositories and sort of, we have our own homes, but we still need the village, center, the meeting place, basically, right? So, okay, GitHub offers many other things also, but the main thing it offers, of course, is these Git projects. Any of you can have your own account. You can host your own projects there. For example, you could fork the project also on a GitHub if you wanted. But okay, so locally on your computer, you need to clone it. Yeah. I provided these instructions for doing it from a command line, git clone, right? But what you can do is also, you could do it from Visual Studio Code, right? So how many people are using Visual Studio Code? Oh, great. About half, right? So I'll show you what's happening there. And basically, right, you install something like this. Actually, I have two different versions of Visual Studio Code. Here's the regular version. I'm using the experimental nightly version. So theoretically, it could crash at some point, right? Theoretically speaking, right? But it has not happened yet, right? The last few weeks. So it's basically means they have the new updates. So it's a little bit, every night they do some updates, and so possibly Microsoft could screw things up. So I will close the folder, right? And basically, you have something like this. If you have installed Git, you have this option, clone Git repository here, right? So this is what you use. You would click, you need the link. You don't have to do it from GitHub. Of course, GitHub is owned by Microsoft, so they offer it to you. But it could be anywhere else. It could be also even your friend's repository on their computer, as long as they have network address, of course. So you would provide this, like this kind of link, basically, and you would clone it, right? Clone from GitHub. Right, and what's going to happen is, of course, I already have it, but it's no big deal. I could do it somewhere else. I will do it as an exploration. I will do it maybe in my documents. I'll do a new. I could do it here in documents, by the way, because it's not a GitHub repository. It's just my regular, my documents. But I'll make a new map, my GitHub projects, for example, my July projects, for example, my July projects. Right, not a great name, but still, right, on. I have it, and basically I will say it here. That's my repository destination, right? And it will clone it over again. So I will have multiple Git repositories from the same project, right? In my computer. That happens. Of course, the question is if you do work on 3 different folders, if you make some changes, right? Then the question is of merging. But yeah, so it's cloning, and we'll see how fast the internet works. It's not a very big project, but maybe about 40, 50 megabytes, right? I have some data files there for those, and it would, let's see, it's about 60% done, right? Maybe we'll see, maybe internet is not so fast. It looks like we'll see, right? Not so great, but okay. So it did the internet worked, and you would say your internet connection is unstable. I don't like that, all right? Thank you, but so open, and I would open it. and have all the files. I have my data files, I have my notebooks. I will, of course, Visual Studio Code will say, do you trust this guy, this author? I guess I'll have to trust myself here, right? You could actually say, my July projects will be trusty. I will only do clone verified authors here, right? So I'll trust all of them. But actually, I could do that, right? I'll trust the authors, right? So, because of course, if you clone a random repository, you don't know what it's going to do. Maybe. So, right. And so I have my notebook. That's how you clone it. And now I will show you, because I had a request. How do you get? So you have your project, right? And notice something here, right? In Python, there's a question: how do you run your code across multiple computers, which we have here, right? Somebody wrote some nice code, well, maybe decent code, but you have dependencies on external libraries, maybe external tools, right? That's part of the strength of Python, is that we have many external libraries. Last I checked, if I check my or trusty Python package repository, not print, I don't want to print something, I want to see the py, yeah, org. Here, right, we see how many, about 500,000 repositories last I checked. Yeah, 460 projects. Of course, Sturgeon's law says, only about 10 or 20% are any good, right? 80% of everything is not so good, right? So, but still, it's a lot of projects, right? Many of those actually are student projects. PyPy actually, this is a central place where you find something. You have some need for something, you should check here first, right? You search, maybe, again, if you have no other clue, right? If there's no any other way of finding things, this is a good starting point, right? So they had some problems, of course. Some people were making some lookalike, typo squatting project names for popular libraries. It's been only for last year or so. Some bad actors actually are appearing, so they are going to tighten up the rules. So if you're a student trying to publish, it's going to be a little bit harder to publish projects on this official main package repository or index. Bless you. So, right. So we have this big list actually for this particular workshop, right? For all these things we're doing, we have a lot of actually libraries, right? So the idea is you have a text file. Requirement, typically it's called requirements, it could be called anything. It's basically a text file which says, okay, for this project, we need these libraries actually, right? So let's see how they install actually, right? So I will open up terminal, right, new terminal. So basically, what's a terminal? Again, it's just a command line, except it's just exactly the same thing as this, really, right? In this case, I'm using PowerShell. Yes, question?
Before this, may I ask a question about Git?
Yes. We clone first. Yeah.
If you make some changes,
yes.
We have done something locally.
Yes.
We cannot safely just pull from here because it will overwrite.
Okay. The question is now, where's it possible if you're working locally on the same file that I am working on, right? And I push some changes to the GitHub, right? There's a possibility of conflict, right? So what do you do, right? In a production scenario, if you have actually two people working on the same thing, you have to have some sort of merge. Somebody will have to be a merge master and have to decide which changes to keep, right? In practically, you could have the good old standby of copying somewhere else, of course, or renaming things, of course, right? Because the main thing you have to remember, you don't have to worry about breaking my code, right? Because I'm responsible for it, right? So you could, of course, also it is possible to push to your own, start diverging from my code and start push to your own repository. If you have your own GitHub account somewhere, right, you could push change where you push the changes, for example, right? And then you would not depend on my updates, right? That's also possible to do.
Did you say that if we use this Git and our local
yeah. Okay, so the way I'm going to do is, since the idea is, I'll see we're starting we're doing some technical talks. Idea, I have notebooks for each section, right? So it should not be, you should be able, there shouldn't be any issues, right? So meaning when you do pull, right, you're going to work on the current notebook, right? So there shouldn't be any conflicts because each time we work on a particular notebook, right? A conflict might be if we sort of go over 2 sessions, right? We work on the same notebook, maybe I do some updates. That's a possibility, right? It is a possibility.
So why I'm asking this because sometimes I'm doing my comments.
Yeah.
And when I just pull everything from the master repository, my comments are being deleted. So for that reason, I'm making a separate folder somewhere else. And
Yeah.
basically make this kind of messy.
Yeah.
Ask what's the way you recommend this.
Yeah, the thing is, basically, you could simply, again, you could pull separately, right? Because what I can do, basically, I could be very I can avoid making the changes here from my side to make your life easy. The changes I make here, I won't push them basically for now, basically onto the repository. But it's really hard to avoid actually because it's there might be some things we come up upon this discussion that I will want to push. So I would say if you want to keep your local changes basically before you do a pull, right? Because again pushing, right, it's not if I push something to the public GitHub, it does not affect you directly until you pull, right? Unless you set up some sort of automatic pooling, it's possible to do it also to do things that update automatically. But so before pooling, right, you might need to copy over your change. It should not overwrite automatically. That is, yeah. You have option. Do I want to overwrite or not? Right. So yeah, there's no really great solution to this actually, unfortunately, as far because it's like each Git is basically its own project, right? It's its own bookkeeping, right? It's just that we need sometimes some data from some other project which might be closely related, right? Very similar, right?
I'm happy. I just wanted to
Yeah.
because
Yes. It's not like there's not really, like I said, besides moving your own files away, because if you pull, because it's the same name, right? It's the same name, right? It's a conflict because you are if you clone this repository, right? It has a link, it has a remote connection to this GitHub other repository, right? The other animal, basically, right? So, and again, you could, of course, if you never update with pool, right? You could, of course, like say, technically, if there's a hidden Git folder, if you delete it, right, all the booking goes away, and it's not a Git project anymore. It's just a folder with some files, basically. But then you don't have Git pull anymore, right? So let's finish this technical issue because I want to get started on. So we have requirements, but this is also applies. It's part of the Python, of course. How do you deal with if you have a computer and you start working on many different projects and the libraries? The issue is, I don't know if you have run into this, but library version, there was some tiny change to some library, and the author, he was well-meaning, maybe he fixed something, but the migration did not happen correctly, and there is some incompatibility. So what the solution to this is? You have this requirements file, which specifically notes the version, right? So you could make this also larger than, right, or maybe less than. So you're saying, you need this version for this library, basically. So the question is, how do you install it, right? So now we come to this question of installing. Again, I assume you have Python installed locally, so you can check Python version. Okay, I have Python version, right? And I have pip version. So pip is the tool you use to install libraries, right? Okay, great. And it tells you where it is, right? It's in program files, Python 3.1.1. This is a folder where you would install Python if you pull it from python.org, right? This is what I mentioned in installation discussion. So here, right, on as a global user for all users on your computer, right? So you just basically get it, download. Is there a new release? No, 11.04 is still the latest one, right? So, like it came out in this June. So, it works, your operating system can find it, that's great, but the problem is now, if you installed all these libraries here, right, I might have something globally here, right, pip list, right, this tells you what I have locally installed right now on my computer for Python 3.11. And the issue is that as your number of different things you work on grows, you most likely don't want to install these libraries because you might break some other library. So that is a very important issue. So what you should do, which is good practice on your Python, is to set up virtual environments. Meaning you will have, basically what you'll have a folder with a Python and the libraries basically just for this project, right? It is not a hard, like a very strong virtualization such as VirtualBox, or there's a VMware, or maybe you heard of Docker, right? Docker is sort of middle ground, right? It's also virtualization. This is really basically just a folder with some links and some libraries and some files just for this, this project. So what you do is, if you are in let's say this is my, this is where I'm keeping my, gonna keep my, this is my project folder, my, so to say, parent folder, I mean the main folder. And so what I do is Python m, right, VNV. So this calls the built-in module, virtual environment module. This has been the standard for last about 5-6 years, right? And then the second part, right, what it's gonna be, it's the name of the folder where you're gonna keep it. You could theoretically store it anywhere in your computer. Some people say make it your own folder just for virtual environments. Personally, I don't like this because then I have to go keep looking there. What I like to do is I just say VNV, right? It's just a name. Second part is just a name, right? It's just a folder name, really. On, I'll press enter, right? So what's gonna happen? I have a virtual environment folder here, right? On Visual Studio Code is smart enough. It tells you a new environment has been created. Do you want to select for your folder? Yes, workspace folder. This is my workspace, right? So yes. So this means it will remember. Yes, question.
One small question before. I sometimes run into the problems that I have to explicitly write Python 3.
Yeah.
But you assume that our Python is 3.
Yes.
It should work like this.
Yeah. So you say you did, if you're working on Mac, Macs used, Macs, Control Z, right? So Macs and also Linux machines have their own Python, which is based on 2.7, right? And that might be an issue. They're moving away from this actually because they use this old Python for some system tasks, right? For automating things, right? And so that might be an issue, right? So on Windows, I installed the latest Python and I tell it where to find it. If you have Python 2, right? It's possible to have multiple Pythons, right? So you might need to have an alias for Python 3, for example. I mean, you could do it it could be like this, right? So you shall check the version. That's why I said check the version first. So what does it give you? Does it give you 2.7?
Yeah, actually, this time it gave me 3.8 already with just Python, but I was just double checking.
Yeah. Yes. So if you're on Mac, yeah, this is a possible, could be a possible. That's why you need to check the version. This virtual environment, the current way, is basically after 3.4 or 3.5 roughly. So last 5 years, Python has a versioning where now for last 11 years you have so each year your number increases. So it's now 3.11, right? So we'll have 3.12 next year, I believe. No, this year, right? So every year there's one minor version increase. So question is, when will we have Python 4? Well, not likely soon, because that would mean some breaking changes. And we had enough pain with migrating from Python 2 to Python 3 15 years ago. Because for first 5 or 10 years ago, it was really, really hard. People were, change is hard, and it was, why change? Why fix things if it's not broken, right? Your scripts are working, everything is working, and I have to learn some little new syntax, and why do I need to change, right? But luckily, now everything's settled, and there shouldn't be any big breaking changes for Python versions for, I would say, next 5 years, maybe 10 years, who knows? But maybe some new things will come in, but the old code should still work. And again, if you need specific library version, right? Again, these libraries, which people, like you and me can build, they can change things, of course. They can break, versions might change. So that's why we are here. That's why we're using this virtual environment to install only specific things. So what you need to do is, the first time, right, and I'll show you how to activate it. So basically what I do is I go to the virtual environment folder. Again, the name it comes from here. I could have made it something else, my virtual environment, right? So virtual environment, right? And again, this is using the Windows. Can you see this in the back? It's probably not hard. Maybe, I don't know if you can make it bigger.
Can you maybe paste it in a Zoom also?
Yeah, I'll show you. So, but basically, all of this is basically, again, all of this is here, right? Maybe my instructions were not completely clear, right? So basically, we are almost done here. So basically, we are at this stage here, right? So this, maybe I can make this bigger, right? Yeah. So we are here. So Python, right? And now we need to activate it, right? Afterwards, Visual Studio Code or most code editors will pick up on this, right? Automatically. Right now, first time, scripts, right? And activate. I'm using tab completion. So again, since I'm lazy, you know, good programmers are lazy programmers, right? So tab completion is great for almost everything, right? So, and this time it's going to be PowerShell because it's a Windows PowerShell. Again, the scripts folder should have some other, so virtual environment, scripts, it'll have like activate bat, which is for the old Windows systems, right? And there's also, if you were installing activate, I think this is a bash script for Linux, and also I think for Mac, the activate will work, right? So what I do is, now I press this, right? And notice here, I don't know if you can see this, but you can see this in the here, right? You will see this part here. So you have a prefix virtual environment. Again, that before your pad, this means your Python is clean, right? You have your own environment for this project. So that's great, basically, right? We can check what kind of Python. By the way, it's possible to install a different version. Let's say you need a project which has like Python 3.5. It's possible to install different versions also, right? I'm using the default version, but it's possible to do it as well. So, question?
So is it the same code for Mac as well?
Yeah, it should be, except it's not PS1. It should be just activate. It should be activate because let's check it, right? Yeah, you see bash. It must be used with source bin activate bash. So bash is for terminal, right? It should work. And if you do it, you should see this. So you go to this VNV scripts activate, and then just without the PS1, right? Because PS1 is for Windows, right? It's PowerShell script. So these are standardized for last 5-6 years. Only thing is, of course, people keep coming up with a better mousetrap. Or yes,
It didn't work for me.
it didn't work. Okay. So what did it say?
It says stop when the scripts activate command not found.
But do you see it here? Is it in the folder? Do you see it here?
I can show
Maybe show it to me.
I can get rid of the backslashes.
Yeah,
For some reason.
because you're using forwards. You should be using forward slashes, right? So it picks up on this. It does use backslashes. Okay. So let's check out your VNV. Check out VNV. Okay, bin. I think it's bin. Yeah, it's bin, not scripts. That's the difference. You see, on a Mac, you have a bin. So
So I replaced scripts with bin.
yes, so that's the thing. So yes, on a Mac, again, sorry, not a Mac person. I mean, I know enough to get around Macs, but yes, so there's a difference in the folders. Yes, for those on a Mac, but Windows people are hopefully it works for the Windows people. Right. So again, okay, Control Z. Again, you see what happens. I don't want to break the requirements. So what happens now is, if I do this Python version, it will show the Python version, of course, 3.11. I don't know if you can see this, right? But and basically, I can check my pip version on. And now the fun starts. And what you do is, if you have this, now did it work? Did it work? Not yet. Okay. It's still.
Actually, I also cannot install it on my Windows.
You were not able to install the Windows?
No, Windows is installed and Python is installed, but this environment I cannot install.
It doesn't.
There's a security issue because this is a university.
That's also a possible cause. Sometimes there are restrictions on what you can install on a computer. So I've had some students, yes, who say, okay, I can only, I have to tell my system administrator to install Python. I can't do anything else. So there might be some sort of rules, what kind of, because what's happening is it's copying or actually making links from the Python, which is in a system folder, right, to your project folder. So maybe there's some sort of rules-based restriction that says, okay, you cannot have any running programs in your user account, basically, right? Don't go around doing anything crazy, right? So it happens, yeah. So again, we'll finish with this because you know, we want to get some code running, right? So again, this is only for those who want to get it running locally, right? And so now the main thing is if you run this command, right? So this command, and again, I'll press it, I'll see what happens. It's actually going to take, I said, it will install everything. It depends on how fast your computer is, right? So it might take about, it will download about 500 megabytes of libraries because there's Pandas, there's NumPy, GenSim, Scikit-learn, all these fancy libraries, right? Which some of them include also some data sets, right? So it takes maybe, I'm not going to run it, the command right now, right? But it will the cool thing is it installs everything. It just goes through, right, this command, and then you can make it bigger, right? So this is a command you should keep in mind, right? So even if you're not running, environment, it will still work. The only difference is it might overwrite some libraries you already installed with different version. And I had this problem before, right, a couple years back, right, and you know, I always said, okay, I don't need these virtual environments, I'll just keep always installing libraries, right? Eventually, it's going to happen. And then you basically have almost no way of tracking down which projects need which version, basically. It's not a version, like I said, it's one of the pitfalls of Python, but most languages will have this problem because, you know, you have different tools, right, with different versions, right? So, yeah, so that's why we need the virtual environment. That's why this is something to keep in mind if you want to working on, again, on different projects. If you, of course, what's an alternative? You could have a real virtualization of, like, you have virtual windows, you know, for each project. I mean, you could do that. I mean, that's even more, you know, using like a virtual box or virtual, you know, there are virtualization, like real hardware virtualization. That's also possible. Or you could have multiple computers. That's also possible, right? One computer for each project, right? That's also possible. So, question? Okay, before we go to actually our Python code, one more question. Yes.
To change slashes to other ways.
Yes.
And then I got permission denied, which is a success, but still not fully.
Aha. So. Right. So I think we are. I think enough technical things. Right. That's why I knew that. If I try to do everything locally, inevitably somebody will have an issue, you know, and it's, you know, it's a showstopper, right? So that's why, of course, cloud solutions are so popular, right? You just click, you have a connection to the cloud, and you let the Google worry about making a virtual machine, installing all the libraries, and doing everything for you, right? So, all right. So again, let's get started. So for those who went through this, who can do it locally, I will be using Visual Studio Code, right? And I will be closing this folder because I already have installed everything in a different folder, right? I close the folder, right? And I will open up this one, not July. I have a D folder with GitHub, which is where I keep most of my projects, basically, right? It's just a folder name, right? And I have everything here, right? But you, right? So for those who don't have a local installation of this cloning of this project, you basically, all you have to do is open up this part 1, collecting data here. Unload it, right? I did open a new tab, right? So this is, of course, Google Colab, right? And I don't know if you can move this. Can I move this around? Zoom. How do I? Hide video. Can I do this? Yeah. Oh, yeah, that works. That's even better, right? So you need of course, it's a Google project. So what they have done is they offer to make you a virtual machine, meaning it's like a computer, but it's not a full computer. It's a part of a computer, somewhere on their servers, probably Finland or Germany somewhere, not in Latvia, all right? Somewhere in Europe, most likely. And you do need to have a Gmail account, so to connect. So basically, right now, what you have, you can read the text, right, for your Jupyter notebook, but you can't run the code, right? So you would need to click on connect, and it will start the process. Did I click connect to new route allocating? So it goes, says, okay, because it's such a very popular thing. It's free. It's a free service for those who have not used it, right? But most of you have used it. And what's the downside for this? For free, well, I don't know if you have used it, but if you go grab a coffee, maybe we have a lunch break, what's going to happen, right? The code stops running, right? They close the machine, basically, right? So what you should do is, if you are working on this cloud environment, right? I think it's 30 minutes, I think, inactivity. I mean, you could. I mean, I've written some scripts. I used to write some scripts which simulated activity, right? So keep it alive, right? But it's still better. What you do is you can just download. That's the easiest. You can download it to your own local computer, and so you know you have it locally, right? It's possible, but there's some other ways. If you have a GitHub account, you could save it to your own GitHub account, and it will let you pick the repository. It's kind of cool, actually, right? So you can have your own. That's actually what, if you're using a cloud version, that's what I would recommend. If you have a GitHub account, it will keep the changes here, right? You could also save it in a drive, bless you. And also Gist, I don't use it as much, but yeah, so these two are options. GitHub I use quite a bit, because if I'm working on this project, I could make changes here, and I would save it, to my repository. Right. So the download, it just downloads the either notebook. There's also a PY file, right? It would just download the script. It would convert to a script, right? This notebook, and you could use it as basically a running program. So let's check again our cloud. I'm not a subscriber. You could pay $10 or €10 a month, but you don't really gain too much extra. They still shut you down, actually. And I think even the Pro version, which costs €50 a month, there's still, right, you can check this, you can check, maybe, I don't know, if maybe your university or maybe your, they search, it's €11 a month, right? So you gain some extra computing units if you need some GPU access, right? Maybe slightly more memory, right? But you still So if you pay €50, you could keep running for 24 hours theoretically, right? So that's maybe worth paying €50 if you don't have your own computer, basically, right? So and you need some serious work, maybe. But I don't know. I don't know too many people who use Colab Pro, but yeah, it's possible. So right. So for now we're using the free version, right? Maybe somebody has a Pro version. Anyone? No. No. Okay. Right. So what you check is, again, they don't guarantee you, but lately, I mean, it's been actually check. So you have about 12 gigabytes of RAM, which is not bad, right? And 100 gigabytes of disk space, yeah, for duration, as long as you're not too far away, right? So, sometimes there's ways of changing it to get some graphical card, resource for some heavier machine learning tasks. Again, it's possible to change it, but it's not too bad. I mean, again, for free, So, and I'll go back to code, right? So this is how you can do it. And basically, I checked. You can run these first, at least today's materials, all will work through Colab, right? Again, so we already, you can see. So again, Jupyter notebooks. Again, I assume most of you already know. What do they consist of? Two types of cells, mainly of two types. But we have what kind of cells?
Code and text.
Yeah, code and text, basically. Yeah, code and Markdown, basically, right? Markdown. What's Markdown? You can tell me. You have used Markdown, I'm sure. Yeah.
Create some files.
Yeah. Yeah. Basically, it's a markup language. It's very simple, right? I think I might have a link to Markdown somewhere here. I will have. Here's my Markdown instructions, but I can show it to you here. GitHub Markdown, right? It's worth spending 20 minutes at some evening or to learning it. GitHub Markdown, on the basic. There's slight variations, but the basics are same everywhere, right? Maybe I'll put a link to it in a chat. Can I get the chat here? And, there we go. How do I get chat here? Maybe I have to exit. Well, basically, you use hash marks for headings, right? Then you use For bold, you use 2-star syntax, 2 stars starting end, italic for single star. On the quoting text, you can use quoting text, and you have also, only the colors, links, you can use a link syntax. You use basically name of the link, and then regular parenthesis has the actual link, right? And images, you can include images, which is what I'm doing here, by the way, right? I'm hot linking to our library here, right? Maybe I can show it to you. Oh, here, yeah. Right? So this is a link, right? You see? I have a heading, right? And I have a link to our GIF file of our digital humanities little thing, right? So dancing human, I guess, right? So banners, right? So that's how. So that's why Markdown. It usually translates to HTML, hypertext markup language, right? But writing HTML by hand, it gets old pretty fast. A Markdown, you could write Markdown, it's just a few extra commands, and it's pretty nice to structure your text, basically, right? So it's well worth learning basics, because many tools support it. I mean, you can write books in it if you want. I mean, there are tools which will take your Markdown and give you make books for you, right? So. Yeah. So similarly, right? So I will be working here, and so few things about visuals. So I'll open up day 1, part 1, right? So this is also a Jupyter notebook, right? On Visual Studio Code, I've been telling Harald that it has great support, right? Also, right? I can click. It's the same thing. It's exactly the same thing. What's the big difference is that it's running on my computer, right? So I told also I can pick which Python to use. I said, okay, use the Python which sits in my virtual environment scripts, but I could change it. I could run like Python 3.6, 3.7. I could change the kernels, right? I mean, I could have different versions installed if I want to, right? So, okay, so we have Markdown cells, right? And I'll have mostly, actually, in this workshop, I have a lot of Markdown cells, because, of course, this is a sort of a more information than, well, coding also will be. But you usually, a good notebook is where you do have some top-level heading, and you also have headings for the chapters. Because why? Because notice something here, right? I have it here outline, right, for this notebook, right? You have a nice little table of contents automatically, yeah? And why do I have this table of contents? It's because I took time to make these Markdown cells with some headings, right? So similarly, for those who have Colab, it's the same thing. Look at this here, right? Look, check this out here, right? Table of contents, right? So this came automatically, for so to say, for free, if you do the time, if you take the time to use Markdown to make your structure your notebook. So, because of course you'll be writing code, but so from time to time you start a new section, right? On your, it's well worth making. Maybe make a small, Markdown cell, right? We call them text. Google calls them text, right? A text cell, right? It is. I mean, it is technically just text, of course, right? But it supports Markdown. I mean, you could write just plain text, of course, as well, right? But then you won't have the chapter headings, basically. Right. So it's good for, yes, question.
Yeah, I maybe missed something. So if I'm using the Colab version,
yes,
then I'm opening your GitHub.
Yes, it's
Clicking on the file.
okay.
How does it open?
Okay, so there's a trick to this. Okay, so I'll show you the trick how it's done. Right. I actually have there is official extension for Chrome from Google, right? Which will do it for you, by the way, which will make you links, right? We're all familiar with HTML, right, with links, because we've been clicking all our lives, right? So basically, it has a special, look at the syntax here, right? You can figure this out, actually, right? So basically, you have Colab Research Google, right? Then you have GitHub, right? Then you have my username, right? Because that's my GitHub account. And then you have my particular project, right? And then you have blob, and that's the only thing you have to add. You have this blob. That's what Google requires. And then it says main. So blob and main, basically, right? And then you say notebooks, You can figure this out for any project, right? Basically, right? So let's go if we can figure this out. I'll show you. For example, check this out, right? Testing your computer setup, right? So here, right? Assumption. So look at this. What I did here. So I don't know. You can see this in the back, or maybe your screens. You're showing. You can see the screens, right? Right. So I have a picture, right? This shows a picture of the Google Colab badge, basically, right? Here, right? This is a picture. And underneath, there's a link. So basically, clicking the picture opens up the link. And you can basically put anything here, right? So in this case, it's the project name, right? This workshop name. And then the blob main notebooks test Python setup. So that's the trick, basically, right? So if you can make links to any, basically, it'll open up anything publicly available, right? Which is a Python notebook, basically, right? In this case, GitHub. In any GitHub project, anything, right? So you can go to some place, right? And so that's why personally I like this, since I'm lazy, right? I don't want to keep remembering blob main, right? So what I do is I have this extension, right? It's called, I will maybe give a link, Chrome Colab extension, right? On open in Colab, basically. It's a tiny extension. It has not been updated in 3 years, but it's owned by, it's Google developed. Somebody at Google, maybe they took some time off, right, from their, whatever they're doing, right? And basically it opens up, if you go to, it's a GitHub hosted Jupyter notebooks in Google Colab. So if I go to some random address on a GitHub, let me go here somewhere. So if I go, for example, I go to my notebooks, right? Again, this is just the name of a folder. It's just, just for organizing things, right? So I'll open up in a new tab. I'm in notebooks folder, right? Here, right? So if I go here, right? So GitHub, right? So basically, GitHub will show you the notebook, right? But it will not run the code for you, right? So you know the difference. So basically, it's like a passive. It's basically give you some results, but you can't do any Python programming, not currently in GitHub. So with this, if you have any right now, if I click this link here, right? It will generate the link for me. Basically, what it'll do is it'll add the Google research, it will put the link correctly. Blob main, it will make correct link. I mean, I could click it. Of course, I already have it open, so let me open some other one. Maybe let me open up maybe this test Python setup, right? So I'll go here, right? And if I click my shortcut, right? And this is how I generate the links, because I don't want to keep remembering the blob main, right? Now I can copy the link and I can make a link, in any place where which lets you make links. So with this link, right, an internet access, you will be able to open up this particular notebook, right? And then you press connect, right? Right. So does this make sense? How Colab works? Does everybody have Colab? I mean, for those who are using Colab, it's working? Yeah? Okay, great. All right, so again, I will be using the local installation, but the code, it's basically, there are some different, I'll show you what the differences are. Basically, if you run this, right, there are some version differences, but so far, I have not encountered any incompatibilities, right? You could check the versions, right? So this is nice because you see it's using Python 3.10.6, right? On those on Colab, right? So it's slightly older. It used to be worse. They used to be like 3.8, right? Maybe 2 years older, right? They didn't, they don't update every 3 months, so the thing is also it's using older Pandas version, which is Pandas just came out with 2.0 version, right? And that's something which might potentially are changing some things for especially working with string data, how they store strings, right? So that's possibility of some incompatibilities, right? But the good news it supports all the basic libraries, right? Again, they're not like latest and greatest, but they maybe, last year or maybe early this year, most of these libraries, right? We could compare it. So these versions, right, if I'll run my test here, right, locally. Test my Python, right? And I'll run it over. So I run all. So it's same commands, right? I'll run all the cells, right? It takes a few minutes, a few seconds, right? So 3.11.4, this came out, like I said, this summer. And the Pandas version is the latest, right? And Plotly version, right? So some things, spacey, what's the difference? Yeah, the thing about versions is sometimes the versions with 0 are a little bit suspicious, right? Because somebody made some new changes. They have not found all the bugs yet, right? So it's also, for example, with Python, usually you don't want to migrate to, let's say, 3.11 came out in November, I believe. You don't want to migrate immediately because there will be some libraries may not support it yet, and there will be some fixes. So maybe like by 1 or 2, you might want to start using it. Right now, it's been 6, 7, 8 months. You can safely use 3.11. Just be pragmatic, right? So again, Google also is being, is going maybe a little bit slower. And there's some companies which go even slower. Again, just use whatever works. Okay, so finally we have some code running, right? So this is basically code cell, right? So we have the code cells and text cells, right? So what does a code cell do? Basically, it's like running a Python code, but it still keeps running. Basically, your memory, your variables, right? They're still available, right? They still remain. If you run you run a notebook, right? As long as you have, of course, connection to the kernel, right here or locally, the memory, right? The data which you loaded stays in the memory. So each code, it could be a separate program, but they share the the memory space, right? So of course, with notebooks, some people really don't like too much. There's some things because you can change the order of execution, right? A regular code starts at the top, goes down, right? But with a notebook, you can play around. You can move the cell. Say you do something, okay, you test something, okay, that didn't work. You can go back and you can run some older cell before. So that's of course real life scenario. When you're doing your exploration, you're doing a text, exploration of your problem space, and it's normal, of course. But that leads to a much harder task. The goal, what you should do, strive for the goal eventually, right? The good practice, right? And I write about this here. What you should do, right, is that I won't run it here, not save, right? So you should some practice Python skills, local install it. Okay, yeah. So text analysis about where they mentioned these good things about notebooks, right? So the idea is that that your notebook should be able to run all the code without stopping with some errors, throwing some errors in the middle of code, right? But it's going to happen if you keep, when you're exploring, right, you're coming up with some solutions, right? At some point you want to maybe organize it so it runs, because otherwise you'll have very hard time. Next time, after a month or maybe after a week even, right, coming back to the correct context, right? So yeah, so that's something that's sort of like a platonic goal, basically like a good idea, basically do, right? What to strive for. So I'll close this test Python setup. So yeah, like I said, it looks like we are gonna go a little bit slower. So the part 1. Yes. Okay, well, but can you for? Okay. Oh yeah. This one? Oh, this one. So you basically run here, new terminal, check terminal. Okay, 1 second. So 1 second. Let's go check. Let's check again. So you have basically, okay, I'll close everything, right? Close folder, right? So if we have blank space. That's the best way to start from scratch, right? So you only have the workshop you have downloaded, right? You have.
Well, I did everything. I just ran this test environment, and now I need to go back. There is a run button on top.
Yeah.
Pushed on it and ran this test and want to go back.
Oh, okay. I see what. Okay.
It's no need to start again from the beginning.
Oh, okay. I see. Okay. You know what? I will take, since we are doing it, maybe I will take a little. I'll check what's happening. All right. So. Okay, you're good. Okay, all right. So, you are in a script for activating the virtual environment. So you just close X, right? Yeah, you don't really, you have it. And so open up terminal. Terminal. Yeah. New terminal. Yeah, just new terminal. Right.
Yeah, but where is this project now?
So check the project. Okay. Yeah, you check here. That's your Explorer. That's File Explorer, basically. Yeah. Okay.
That's all.
Okay.
That was my question.
Okay.
Go back.
Okay. Yeah. So yeah.
Just because you didn't explain.
Yeah. Yes. So there's a lot of buttons. Of course, Visual Studio Code. It can be used for so many different. Yeah. Okay. Great. All right. So now, okay. So I will be using a Visual Studio Code, but again, so what's the difference? One difference is if you're running it from the Colab, right? You don't get access to the data in repository. That's why it's a slight challenge. What you get is, if you check the File Explorer, right? Google gives you some sample data like housing tests and some number tests, but basically you don't get the data, right? So the data will have to come from somewhere, of course, right? And so it's easier, of course, locally because you could just, you don't have to download everything. You can read. It's going to be faster especially if your network connection is slow. But it looks like it's improving. Okay, so that's good. Right. So we'll go to. So our plan is for plan of attack. So what we want to do is basically we want to load some corpus, right? Some documents, right? And we want to basically clean it, preprocess, and we want to generate some embeddings, right? So what does it mean, embeddings? We want to convert the words, or maybe sentence, mostly going to be words, to some numbers, basically. Why numbers? Because most algorithms and computer algorithms, all the cool stuff, well, they need numbers, right? Not strings, not text, right? So, so that's our plan of attack, right? The first thing we'll do is today we're going to collect data and preprocess, right? So, and hopefully we'll get to embeddings. I'm not sure we'll get to embeddings today, but we'll get to embeddings and we'll get to some, maybe hopefully get some topic modeling, hopefully. Right, so the first thing is, of course, we will want to get some data, right? And so let's talk about this. So where do we get data, right? There's going to be a workshop on web scraping, I believe, right? Yes, so that's one possible source, right? You have some resources on the web, right? Social media, right? Generally a good idea is to use an API access, meaning you have not web scraping is basically when you don't have this access, right? So I'm sure there are people scraping Twitter somehow, and of course Elon is fighting against them, right? But it used to be Twitter was a great source for data. For I don't know, last 15 years, I think roughly, some people even built big projects on this ability to scrape, to access. They were actually paying, but there's ability to freely access Twitter data. Right now it's not really, it's complicated, right? So, of course, books, again, depending on where you work, what kind of licensing issues you have. But for example, access to books might be, somewhat limited, right? We have copyright issues, but Project Gutenberg, for example, is a great source pretty much across the world, right? So, news articles, again, depends if there's an article as an API, which is, a programming interface for organized access. Of course, we have Archive and some other places, for research papers. We have Wikipedia, which provides an easy way to get data. have blogs, email. There's some email data sets, speeches, right? There's some, of course, you have some curated data sets. You know, Kaggle, right? Also another Google project. They bought it for data science. But problem with Kaggle data sets is you're really not sure how they were collected, right? Maybe for research purposes they are okay, but if you maybe want to publish, you might have some, I don't know, some licensing issues possibly. There's even dataset search, right, by Google, where you can enter what kind of dataset you want, right? And then there's data.gov for US data. There's European data portal. There's even Latvian data portal, right? How many people here are from Latvia? Most, right? Yeah, right. So, or at least can speak some Latvian, right? So yeah, so that Latvian data, but you don't even have to speak Latvian. If you're working on Latvian research, you can use this portal, right? Of course, maybe you have some your own data. Maybe you went into field, you did some collections, maybe, right? You interviewed people, maybe you measured things. That's also, of course. So what I'll be using for this workshop, we'll be using Clarion, right? Some of you may have used Clarion, of course, right? It's a reputable source of data, usually by research organizations. They support, they offer their corpuses, right? So for this particular workshop, we will be working with Old Bailey corpus. I don't know if anybody has used this corpus before. Anyone has heard of it? Maybe sometime, maybe. Right. So it's a corpus from the criminal court in London, 1674 to 1913. Right. They offer it on they have their own website. Why they pick this corpus? Mostly because it is available under Creative Commons attribution license, so there are absolutely no issues, right, for a workshop setting, right? So it's basically freely available for use for various purposes as long as you give proper attribution, right? So I kept the old license. So it's about it's pretty large corpus, about 200 megabytes roughly. So I know the connection might be slow, so this is going to be a small subset. What I did is I took for each decade from 1720 to 1913, I took one, basically a selection of files. So it's going to be about 15 megabytes roughly to download, right? And of course I only have it here, right? So Creative Commons license. So again, what format is it? It's actually we're going to be using XML. I picked because it's a really hairy format. XML is a pain, so we will deal with some pain with XML, right? Of course, there are other formats, you know, JSON, text, you know, some other things, maybe CSV, right? Excel, possibly, right? But XML, it's not really, it's theoretically speaking, it's a good format, right? Because it offers a high flexibility. It's supposed to be humanly readable, right? Right? For those who have read XML files, I don't know, your eyes will hurt, right? So data is available in various formats, right? So we'll be using a local setup, right? If you're using a local setup, you can already access this data. However, for those who are using a Google Colab, you will need to download, because if you go to our Colab, right, there's no data, right? So we will need to download it, right? So let's look at next how we download data. I'll provide some, and also have some good practices for creating notebooks, right? So we already talked about markdown cells. You should be explaining what you are doing and why, right? And here's the cheat sheet. Here's a link to the cheat sheet, to the markdown cheat sheet, right? When I mention the headings, they will serve as a table of contents for your notebook. On your comments, right? Write plenty of comments in your Python code, and mostly why. Right? Why you're doing something, right? You shouldn't say what you're doing if you're printing something. It's kind of obvious that you're printing something, right? But why you're printing something, that might be, you know, much more important. Also use descriptive variable names. Avoid using short, you know, A, B, C, D, E, F, G, right? Not a good name, right? Because you will not make sense of it afterwards, right? So these are just some common like suggestions, right? Again, try to avoid these single letter names as much as possible, right? And we talked about Git version control, and there's a note about this, right? What is a notebook actually really? If you looked underneath, it really is a JSON file. So how many of you have used JSON files? Some of you, yeah, most of you. right? So it's actually maybe a little bit more pleasant format than XML actually to read, right? So actually, but for Git actually or notebooks, right? Notebooks are stored in JSON format. The changes, tracking of changes, it's still text, but it's not really it's not perfectly suited for revision control actually. That's one of the issues with notebooks. Tracking changes along notebooks is not easy actually. So, right. So your notebook should be able to export. You should be able to export it run it as a standalone Python file. That's a goal, right? It's not always possible, right? So, but possibly, right? You should be able to export it again, like in here in the download as py, right? This file, when you download, it should run as a code. I mean, that would be a good goal to strive forward, right? Or clicking run all, right? Should be able to run all cells in order without any errors. Okay, so we are almost ready to do some coding. Our first code. So our first code, we'll run the first code, and what do we do first? We import the libraries that we're going to possibly need, right? So this is going to be, I'll be running cells one by one, right? So we need to import system is for just printing the Python version. It's just a little sanity check, maybe using some really strange version, right? Again, why should you do this? Because, again, for reproducibility reasons. If a year or half a year later you want to check what happened there, you'll see, okay, I was using Python 3.10, okay. If something goes wrong, something doesn't work, you will have some hooks, some ways of going back and backtracking, how to get this thing working again, right? So avoid any, also versions of libraries, right? We will be using, we'll be using requests, and most importantly, we're using pandas, right? So pandas is a pretty big library. So how many pandas users? Again, about half. So, right? Again, it's a big library, right? Very powerful, right? So again, we'll be using some pandas today, right? So print pandas version, right? So I'll run this cell. I can click here, right? Control Alt Enter, I believe it is, but so I will run it, right? If you are here, right? I'll close it here. I'll maybe, since I'm lazy, data collection, right? Yeah, right. So finally, I'll run this also. Check if it works. Again, it warns you. This is not a Google project. It's my project, right? So it's not going to ask for any credentials actually, but we'll be downloading data of course, from this repository. So I'll run the code, and you can see again. So this is similar how we set up Python 3.10, pandas version, right? So now let's get the data. Yes, question. Yeah.
It did not explicitly install packages.
Yes.
Is it being done on the background?
Basically, since that's kind of cool. The cool thing is about this Colab is that it has a pre-built, operating system image for, I think it's like Ubuntu or Linux something, but which includes all the libraries basically. So when you spin up, you have connection, right? It has a pre-built everything. Basically, it has installed some versions, right? Basically, I think every year or maybe, I don't know, every 6 months, they create this image for, this is what you get, right? You can install, we'll go through, maybe we'll need some libraries tomorrow. We can install extra libraries, by the way, right? Yes, using pip install with the exclam mark, right? We'll get that, yeah. But for now, we're using what Google gives us, right? So, and hopefully we won't need to install anything over, but we can. Right, so of course we need the URL, universal or unified resource locator. And so if you go to this address, actually I won't go to this address, I'll show you, basically I have the file, I made this curated set of data. It's in here. It sits here, right? It's a zip file. It's this one here, right? Yeah, I believe it's this one here. So if I go here, open new tab, right? It's too big. right? 2.7 meg. It's not really that big, but still, it's not going to show a zip file. Zip file is a binary file format, right? You can't just, there's not much point looking at it directly, right? What you can do is, of course, if you don't have Git or anything, right? I mean, if you didn't have Git, you could just download raw, right? You can click this, it will download the file to your computer, right? But we don't want it on your computer. We want to have a programmatic access to this. We have a URL address. How do we use Python if you have an address, how could download files? Well, so here's the recipe. So this might be something useful, right? So we have URL. Let's print it. Of course, we can print it. Again, I will use mostly, it's the same thing here. I will do it here. I wonder if I can change the font during the break. So I have the URL, right? Okay, looks okay, right? Again, the thing is, if I clicked on this, right, it would actually download the file to my computer, I mean, on my downloads folder, right? But I don't need it, right? So let's create a temporary folder where we're going to store some files. So again, this is the recipe. We are at the current, so let's check where we are, right? And we will make a folder, a temporary folder, where we're going to store these files, right? And also, with this recipe, if it exists, we're not going to do anything. Basically, we skip, we are not, if there's already a temporary folder, in fact, I have one here, right? This command will do nothing, right? So what we're using one of the later standard libraries, pass, from pathlib, right? We create this pass object. And why do I choose this? There's an older way of working with OS, because of operating systems, right? With this approach, it should work. It should work on a Mac, and it should work on a Linux, it should work on a Windows machine, right? So let's try it, right? Let's run it. So I am here. The thing is, all of us we are in different places. You see, I'm at a D drive, GitHub, workshop notebooks, right? You probably have something different here. If you run it from here, let's check where are we here, right? Content, actually, right? Turns out there's a content folder. There is a big, lots of folders underneath this, but we are actually here. This is called content folder, right? Here, right? So that's what Google says, right? In their virtual machine, right? So where are we here, right? Now, also, of course, we know common error with working with notebooks, you forget to run some cell, right? And then nothing works, and you have to go back which cell, right? So, yeah. So again, that's why I said it's good to have it. The goal is to have everything working from top to bottom without any interruptions. So here is the next recipe: how to download something from the internet, right? You need a file, right? And it might be a pretty large file, right? Small files might be easier. So what we'll do is some extra things, right? This is not too complicated. Also, we'll use, we also need the file name, right? We need the file name because we have a URL, right? We have a URL, right? So how do we get the file name from this? It's a very old technique. We want to get this. How do we get this, right? So what's the easiest approach? Anyone? I have this URL. I have this string, basically, right? I have the address. How do I get the file name? Okay, so this is yes. We're gonna use split for this on. So we split. So we split by forward slash, right? Yeah, and last part of URL. Right, so, and the good thing is I didn't have to write this explanation. The Copilot did for me, right? I started writing first two letters, and it took over. Yeah, it picked up on my thoughts. So -1, it's the last entry, right? And again, of course, it depends that you know that there is something to split, right? Well, actually, I mean, even if you have nothing, it will still work, because -1, you'll still have something, right? So, because what does split do? If you have a string, split is a great function. It returns a list of substrings using separator as a separator string. By default, it uses any white space, right? But here, And we will be using that later on. But here we are using / as a splitter. So now, yeah. So basically what I said is I want to split this text in multiple parts. I don't care about the start. I just want the last part here, right? Very common. I mean, we could have used regular expressions. We could have used some other things. But this is simple, right? Simple way of getting something you want, basically. Right? Yes?
I have a question related to the previous, where we had this folder name content.
Yes.
So it is not related to the specific color notebook, but it's
No,
more related
yeah.
to my profile.
Basically, everybody, all of you get content, right? All of you get content. Basically, I'll show you some things. You can go actually up. The thing is, last time I did this, there was no way to go back, but I'll do it since I don't really need this right now. So if I go back here, right? Bin boot. This is a Linux system, right? Right? Tools. You see actually what's underneath, actually, right? So you have a content folder. They call content for, I think it might be even a shortcut alias, right, for the user for that particular. So everybody gets their own content folder, right? So now the question is, how do you get back, right? It should be a home folder, home, right? But the problem is you don't have anymore. In a regular system, this would have the usernames if you're using Linux, right? Unfortunately, you don't, right? So right now, basically, I have to restart. If I want to get back to my file system, right? I won't be able to reset, basically, right? I can't go up, basically. I can't go down anymore, right? I don't know, because I don't know where to go. Maybe it's here somewhere, right? No, it doesn't look like it, right? Local, maybe no. Variable, no, right? It's somewhere, but I don't know where, right? So, because in a regular system, if this is Ubuntu, right, you would have it here, right? There will be a username. But first of all, I don't even know my username here, right? It's whatever Google decided, right? It's it's a fleeting, it will go away. So, and it's also usually we don't care about it, right? So yeah, so I ruined my file. I just can't see the files here right now. I will have to probably restart it here. I mean, it's not the end of, I can still run the notebooks. I just don't see the file explorer is basically sort of not working. I can't, I don't know where to go basically, right? So it's kind of interesting. Content. Oh, here's content. Maybe here. Oh, there it is. There's content. But again, it's now. So there's actually it's in a root folder. Actually, turns out, right? Content is here, right? So I can sort of, but I can't. You see, since most people don't want to see all this dirty laundry, right? They just want to see what's their current, working folder. So so Google by default only shows you this part here, right?
So my thinking was, is it a good practice to save it in a content folder because it will be available for me later?
No, it's not gonna. It's gone. It's gone. It's gone forever. It's gone. That's what I'm saying. It's just it's remember well, we go and getting lunch, all your data will be gone. You have to restart.
If you want to keep it for you for later, you have to mount your one.
Yes, drive. So that's So the cool thing, that's very great tip. You can. So what you want is you want to mount your Google Drive, right? So that's how they hook you in with all these services, right? So you can mount the Google Drive, right? And then if you save in your Google Drive folder, then it will be, you'll have persistence. You will gain persistence. Okay, great point. Yeah. So, and that's again, I avoid all these problems by working locally, right? So, yeah, but again, it's a price to pay. Of course, it's a setup time. Once you get through this local setup, right, it's much nicer, of course. And I can be on a beach working on my data, and I don't have to worry about internet connection, right? So, okay, we're almost ready for the break right now. So, but looks like I said we're not going to rush things. So I'll show you, but let's get the data. And we'll do it, I guess we'll do it afterwards again, right? So I'm going to show you. So I have the file name, right? Here is a recipe, right? And we'll go, maybe after the break, we'll go over it in detail. So what I do is, it's a zip file, right? So we needed binary, right? So we're going to open up a file object, a file stream in Python, where we're going to write. So WB means we're going to write binary, right? In this case, we know it's a binary file, right? So And to speed up, right, we are going to actually, we're going to use it for large files. You want to chunk it. Basically, it doesn't download everything, doesn't try to download everything at once. It might not be impossible. There might be limits for download. I forgot, depending on a server. So you want to download in smaller chunks, right? So I have a URL. So I'm using a requests library. It's a great library. It's not a standard library, but it's like almost standard library. Why? Because it lets you act like a web browser, basically, in a smaller sense. I'm sure you'll be using requests when you do your web scraping course, probably, right? It's a great library. So what you do is you basically give an address, right, and it's going to make a connection, right? Usually it's going to be a get. So basically, when I go somewhere with a browser, usually I make a GET request, right? If I'm not submitting any forms, right? And I say, but here I will allow a timeout, maybe 10 seconds, right? I believe stream through, allow redirects, right? And then, what's TQDM? TQDM is purely cosmetic. You could actually just skip this, but it's basically a progress bar, basically, right? Sometimes if you're working with multiple files or something, a collection, it's good to see a progress bar sometimes, right? So we'll see how fast it goes. It also can show you how fast what you're doing, right? Also I'm setting, I have a response, right? I'll be getting a response from the wherever server I'm getting, right? And I'm not gonna just immediately try to get everything. I'm not going to be greedy. I'm going to go it chunk by chunk, right? And then what I'll be doing is, right, I will be writing that particular chunk. So hopefully, right, if it's like a, I don't know, slow connection on a huge file, it doesn't break down. I mean, you'll still be able to resume, but it'll be a little painful, right? So I'm writing it in small increments, right? And then when I'm done, right, and potentially if there is a error or something wrong with the server or my end, I can also get the error message. So what's interesting here is I'm using the so-called Viz context manager. So what's cool about Viz is that, for example, for files, I don't have to worry about closing files, right? We all know how working with files, it doesn't matter Word or Excel or anywhere, right? If you forget to close something, you try to open it somewhere else, right? It'll be a problem, right? So Viz is open, right? Is a standard way of working with files, right? And here also, we're using multiple context managers also for requests because we are getting partials here, right? So all the cleanup will be automatically done with these context managers, right? If you wanted, you could also write your own functions, so objects which do this cleanup for your own objects, but we're not going to go into this today, right? We just use the provided ones. So let's see if it works, right? I'm talking about, let's see it before break. Yes, see, it's slower, much slower than my home, right? You see, it took me like 3 megabytes a second, right? It's like 100 kilobytes because all of you are doing it, right? Right? So, on 2%, is it really going to stop? That's going to be horrible. Or maybe it's saved. We'll see. Let's check the size. Well, is it still running? Oh, no, it's finished. It's finished. It may be the progress bar, maybe. Let's check. It should be like this size. Yeah, it's correct. Okay. We'll get into checking it afterward, but let's see it here, right? So let me run it here. I have the URL. I have it. Okay, I have the folder. Let's do it. I'll run it here. See if we have it. Oh, yeah, it's faster from the Google servers. And do I have it here? Come on. What's happening? You see? I can see this. Oh, a temp. You see? There's a folder temp. I made the temp folder, right? And there's old Bailey. Again, right now, again, we go to lunch. We'll do it over, right? Right. So, okay, question.
Can you say a bit more about this chunk thing?
Yes.
What's the reason? Because if we download a half a big file and it crashes, can we then...
Basically, yeah, that's the idea. Basically, we are writing so we can resume, basically, right? And it could be painful if it's really big, but at least we have it, right? If I made I think there's a progress update. It's TQMDM, but if you know where you stopped, right, you can. Well, I'm not writing it here. In this particular case, I'm just writing, I'm not making a note of it somewhere, right?
It should be theoretically possible.
Yeah, you're precise.
Files you just download some partners and you access it and download the rest.
Yes, exactly. But the thing is, because why I'm doing chunk, you could play around with this chunk. But the thing is, for big files, you can't just download all. If you make a request to it, right? There are limits, basically. It won't give you all of it at once, basically. And it will just say that you don't get the file at all. Yeah. Browsers handle it for you, right? So that's why we added this chunk thing. Okay. It might have, you could try this writing, maybe this is 2 megabytes, not so big, actually. It might have worked, but not guaranteed. Okay. Did it work for everyone? Great. So I think we're ready for lunch? Yes. Okay, cool. So yeah, remember, we'll do this over again afterwards for those on Collab. Right, so were you able to follow this most? Oh. Right, good. Okay, so let's continue. We got started with our first notebook. We downloaded the file, right? So if you're in a Collab, and again, if the Collab is not, is already, it's still actually, it looks like it's still alive, right? Let's check. Let's check, is it still alive? It looks okay. I'll go to data collection. Let's see, do I have files? I do have files, looks like, yeah. All right, and let's check, is it still running? Yeah, it looks like it's still running, everything. So actually, we didn't lose. I guess maybe they increased the limits. Maybe they increased the limits. It's too loud or too quiet. Okay. They are more, so the more frequent user you are, they give you more time. Okay, so if you are like only like once every, 3 months, they might. Yes, okay. That's good to know. So they want to get you addicted, right, to using Collab. Okay, all right. So, but I will be using, of course, locally, right? So what happened is this recipe, right? So this recipe will work for downloading files which are even large, right? Again, there are other recipes which you could download smaller files without this chunking, for example, right? But this example shows how you can download even 100 megabyte files should work, right? Because again, if you download some big files, it might not it might get stuck basically otherwise, right? So okay, so now in our temporary folder, right? We should have a file, right? And we should have a file. Let's check. Let's check the file size, right? And also, originally, those who had local, here's the instruction for checking the file size on the local, right? You could kind of compare. Did I download the same thing I have locally, right? But that is not really useful. But what might be useful, sometimes if you encoder some resources, they will provide some sort of hash, meaning it's a signature, cryptographic signature, basically, right? And I'll show you how you can do this, right? So here, this is standard library, hashlib, right? And I will calculate the MD5 hash. It's actually not a very secure signature, but it's good enough for checking, right? So not good for signing your documents, but good for checking. And you can find out what the signature is, right? So let's see, it's still the same file. So I know for sure that right now I have downloaded the same file I downloaded before, right? So what many data providers will give you, they will give you the signatures on their web page, so you can check, did I download the whole thing? Even like Windows operating system, if you download the image, right, it will provide the signatures. You can check, did I download something? Or maybe I was downloading 5 gigabytes and I maybe made your computer, something went wrong, and maybe there's a bit rot, maybe there's an atomic race. I mean, it happens actually, right? You know that roughly, I think if you have like 16 gigabytes of memory, there's a paper on this, how like once or twice a month, 1 bit somewhere will change due to cosmic rays. Maybe not here, maybe we have a lot of stuff above us, but if you are outside normal space, yes, something will change. Obviously, if it's like a picture or something, you're not going to notice, right? But if it's some crucial instruction or something, right, it happens. And actually, it's been actually a big problem for Google even 15 years ago, right? That they were encoding some errors because they were dealing with so much data. They were actually, they had to come up with some extra error checking, right? Solution, of course, would be great if we moved our memory to error checking ECC memory. Unfortunately, consumer hardware still doesn't support it too widely, right? If you're using professional server-grade hardware, will generally have error checking. So that's a little aside. We can check whether we have something. So this is also something to keep in mind. Depends what the site offers, right? This is MD5. They also have SHE1, SHE256, right? Some other other signatures. Let's see what they have actually. Hash lib, right? Dot, right? And let's see. They have Blake. They have MD5, script. Lots of signatures. So probably the one you want is going to be here, right? So you can use this recipe to generate from a file, read the bytes, right? You read the bytes, and close the file, and you can check whether what you have, basically, right? So, okay, so looks like we got the right file, and now finally it is a zip file, right? And again, it's a very common format, right? It's a compressed file. And so I'll show you here just a simple recipe for extracting, basically, right? So we're basically going to extract everything, preserving the original file structure, right? So I just came up with a pass. So notice again, I build a pass using this / syntax, using the pass object. So again, it should work on a Mac, it should work on a Google Colab, should work, which is Linux, and it should work on my Windows machine, on your Windows machines also locally, right? And basically, that's what I'm unzipping, right? And this is where we're going to unzip, right? So, looks okay. Again, it will be different for everyone. Let's check what it would look like on our Colab. Let's check. We have our download. Right, styles, do we still have it? Yeah, I still have it here, right? Hashlib, let's check, is it the same one? Yeah, same file, good. And let's unzip again. So notice here's going to be content temp, right? Content temp, right? Here it is actual, real, absolute path, right? Here it's actually showing, in the Colab it's showing so-called relative path. It doesn't show you the full path, right? Or maybe actually it is full path, it's just actually the root is here actually, right? The way Google set up. But here I have D drive, you probably have C drive or E drive, any drive, right? And you know where we're going to work, right? So extract, this is a simple recipe. So we are using context manager, right? So we say we're opening this, basically this is what we call a zip file object. Basically we provide a path where the file is, and then a simple, you just say this folder and keep the structure, right? So again, you can automate unzipping of all your files if you want using this, right? So sometimes you have a really zip file with maybe, I don't know, even gigabytes zip file. You might not want to extract all the files. It's possible to go through the zip file and only work with some specific files inside the zip file. That's also possible, by the way, right? For now, we're just extracting everything. Let's do this, right? On pretty fast, 0.1 seconds. How about here? Should be also fast, right? Also, 0 seconds, basically, right? So unzips very quickly. Again, so unzipped, it's probably here. Let's check. All right, so temp, how big is it? Properties, right? About 44 megabytes, but that's because I unzipped everything. I think I have some extra files. Oh, I have some extra files too, right? So not every, again, this is a folder which I don't mind, destroying afterwards, right? It's just temporary folder, right? So now let's check. Next recipe is going to be how to check whether it's a file or directory, right? You have a folder name. This is just a folder name, right? Let's see what's inside, right? basically, so I have file, directory, file, file, file. So I have a directory called OBC texts, right? That's just going to call the files. That's actually what we want. That's where our files are inside the one, or actually corpus is there, right? And the rest of files, you won't have so many, because I have some extra temporary files which I have added and I have not deleted yet. Some of the, partial, some work in progress files again. And again, the point is I don't commit these to Git, right? I don't commit these to Git because it's just not meant for external repository. Right, so this recipe, I think you can follow this. So we give any folder name, so any string, right? And iterate directories, meanings you can loop through. You can loop through, and here, of course, you could add it to a list or something, maybe save it, right? For example, next recipe is going to be how to get all files in some folder. Right, and there are two ways of doing it, right? You have a folder name, right? And you have a glob or R-glob. So what's the difference between these? And this is our friend wildcard, right? So it's something very similar to Windows Explorer, right? When you search this PC, it's just basically the same thing, right? It works very similarly, right? So we can search some map, some folder, some maybe C drive, maybe whole computer, right? So here again, you say where do you start, and in this case, we start in the unzip folder, right? And then I search for everything in this case. So let's see how many files I have. I have everything. I have a file for file, unzip. I have 28 files now, right? And it's just a mixture. Notice how this gives me the full path, right? So it gives me like temp license, temp CSV files, right? So how about finding only XML files? Because that's what we want, right? So we're going to adjust our recipe with the R global star, right? .xml. So basically, I'm sure you all use this in one of your own computers, but we're searching for a wildcard, any file which ends with XML, right? Pretty simple. So, and it will give us a list. So, I don't know how many use this, but this syntax is list comprehensions. So, how many people use list comprehensions in Python? One person. Rest are afraid of list comprehensions, right? So, so file for file, right? So maybe if you're afraid of list comprehension, it's just a way of writing loops. It's just shorter. So maybe let's explore this a little bit, right? So the syntax, right? Because it's very convenient when you're working with some collection. You want to filter it. You want to maybe do something, and you don't want to write six lines of code. You can do it in one line. But I'll show you how to do this same thing with loop, right? So let's check this. Let's check documentation for this, right? So path, right? I create a path object, and it has this glob or R glob. So who knows the difference between R glob and glob? Notice R means recursive. So this will go through all the subfolders and subfolders. So it goes all the way. It will check everything, right? So it works like very similarly how the Windows one works. Glob will only look in the current directory, right? Only the one you're working with, right? So generally you want probably R glob, right? Depends, right? On the pattern, of course. So, but what it gives you, check this again. Visual Studio Code gives you the documentation. Let's see if does Google Colab sometimes gives you documentation, sometimes doesn't. Let's check. Let me loading. It should, yeah, it does give you the help also, right? It depends on your connection sometimes, right? Sometimes it doesn't give you immediately. So you can see, again, you don't have to go through a book, right? Generally, a good well-designed library, like Path, of course, is a standard library, right? It gives you the method names, what you can do. The only thing is, what is this generator? You're not getting a list back. You're getting a generator object. Who knows what generator is? Basically, it's like I would say it's like a half-ready. It's like a list. It's not really a list. It's like a lazy list. Basically, it gives you information only when you really ask for it, right? It yields. Basically, it knows how to get stuff, but that doesn't give you immediately, right? So why in programming, why do we use this? Because we might want to chain these together. We don't want to keep everything in memory immediately. You sort of like go through something only when on need to know basis. But okay, but let's see how we could do all of this with a regular. Let's get. How is it? Can you see this on the screen? How Zoom? Okay. I wonder if okay. Now the question is for me. I know you can change font size. There's million settings, right? Nobody can profiles, settings. Let's check. Maybe I can increase the font size a little bit. Text editor, right? Font. Okay, there we go. Consoles, of course. Yes, font size. How about 16? That might help. Maybe I'll do 18. Maybe font weight. No. And let's see. Questions. Will it apply to? Okay, 18. And the question. Will it save? Okay. Yeah, I think it did. It is a little bit bigger. Yeah. Yeah. Okay. All right. So let's get the list version. Right. So list version of the above code using regular loop. Right. So XML files. So we start with empty list. Start with empty list. Right. And now maybe I'm gonna to say XML I'll call it 2 or else or 2 maybe, because so we can see what actually same thing, right? And then we're going to loop, right? For file in path and zip folder are glob, right? So again, generators are great, right? So R glob returns generator, right? Generators are great for looping through. Yeah. So that's why typically dealing with some larger data sets, of course, gives you, so it only gives you, maybe you have like in your system, maybe if you start, if this instead of unzip, you gave it like a C, right? Root folder, you might get like, I don't know, 100,000 files, right? And again, maybe you don't want to just have them all directly. But what you want to do is maybe only get the ones you need, right? So here, of course, this is XML. I could add some extra logic. I could add some extra logic, maybe for size or date modified, right? Because each of these will be a file object, right? But for now, I'm just gonna pen. So basically, that's what it is, right? On print length, how many we have? That's gonna be length. Print number XML file. It should be how many? 20, right? Let's check. And maybe let's get the last ones. First 10. First 5. I'm lazy. Yeah. On a little trick here. Right. So let's run this. Yeah. So I have 20 files, exactly the same. So it looks like 7247, right? All these files looks like exactly the same thing, right? So if you don't like list comprehensions, right, you can use it. So this list comprehensions helps me avoid this this type of syntax. I start with an empty list, right, and I build it up, right? So yeah. So again, so if you're afraid, if you're not yet used to list comprehensions, it just saves a little bit of time, but you know, you don't have to write as many loops directly like this, right? So that's something. So list comprehension, yeah. All right. So we got our files, our globe. I could have added maybe some size, maybe, right? Some extra information here, right? Okay. On I have the first 5 files. So yeah, let's talk about this little trick here. I don't know if you have seen this trick with the star. What's happened here, right? We know about you all know about slicing syntax, right? We have a list of something items. We can get a slice of these items. So what does slice return? Usually, you know, another list, just a sub-slice, a slice of a list, right? Okay, but I wanted to print these items one by one, right? So what I did is I so-called unrolled this, right? So what I did is the star says, okay, I have these 5 values, right? It could be 100, maybe 10. But print function, notice something here, right? It takes the star. So it takes unlimited number of values. You can print like 10 different things, right, at once, right? So what I did is, this is basically for purely cosmetic reasons, right? So I said, print this part here, right? Print this, comma, right? And then here I have 5 values, one by one. So it's not a list. So basically, by using star, I passed these 5 values one by one. And so what did I gain of all this extra? It's just purely cosmetic. I gain the ability to pass extra separator. By default, what's separator? By default, it is space, right? So I said, okay, I want a new line. I have 6 values. I have this text here, right? This here, new line, because it's separator, right? And then print them one by one, right? If I did not use this, right? Without this, let me see what happens if you don't use this. Come on, I need to. I can lower this here on, maybe make it a little bit nicer. Yeah. Okay. I could do the. I could print without unstacking. Yeah, let's try it. Yeah, shot this way, right? Same thing. Only thing, separator is not needed anymore because it's we're not using it, right? So what will happen here? Space. Of course, I need to close this here, and it will be just a little bit uglier. That's all it is. You see? And also another difference is that it also tells you when I print the list, it prints you what kind of objects they are. These are actually not strings; these are window paths. If you are on a Mac, you should seeing something like a POSIX path, probably POSIX path. Probably on a Google Colab, you see probably POSIX path, right? Let's check. Is it here? Right. So this just prints this, right? But if I print it, let me make a new code, right? A code. So I will copy it here, right? It should give me first 5, right? I'm not going to save this. This is just extra like this, right? Without unrolling, no unrolling. First 5 files, of course. It's what I'm doing, what I'm saying I'm doing could be two different things, right? So let's see. Yeah, you see POSIX path, like I said. So what's POSIX path? It's a standard that's followed by Linux and Mac, actually, right? So Windows is the odd man out, actually, right? So it doesn't follow. It has its own standard, and that's again it causes us pain, actually, when working with files. And part of the reason you see how it's using backwards syntax, right? So generally, on Windows, the forward syntax also will work, right? But so it gives us issues sometimes. Okay, so now I'll show you. Let's go to next recipe. Let's sort it. Let's sort the files, right? And if you remember, it's a list of files, right? So list has a built-in sort functionality, right? We could sort directly, but here we can basically provide, since these are objects, they have some properties. We can sort by name. So basically I'm saying is, so sort has a key parameter, right? And key will take generally a function, right? Key function. So it's an optional option that we say, okay, use some way of maybe length, maybe name, maybe some, if you have ability for some maybe file size or something like that, you can sort it. So let's check what happens here. On name error, because I didn't, what happened to my XML files? Oh, XML files too. Oh, I didn't save these. I didn't run this code. I thought I did. Oh, you're right, you see. No, 13. No, I did run it. Okay, here, let's check. Yeah, okay, so I sort by name. In this case, I think it's exactly the same, but let's see, how about sorting by, I don't know, file size maybe, right? Let's sort, and I will, let's sort by file size in a new list, right? So I'll do this. So instead, so what's the difference here? Sort and sorted. What's the difference? Who can tell me the difference? like a philosophical difference between what they do. They both sort something, right? They both sort, but what's the difference? Who can tell? No, it'll take any collection, so anything which is in collection. They're both right, but the difference is how it's syntax-wise. This is you pass in and you get something out, right? So this is so-called out of place. Yeah, we use out of place sorted, right? So if you click, right, sorted, right, returns a new list, guarantees to return a new list, all items from iterable. So XML files, it could be what can it be? It could be what's iterable? Any type of collection which you can loop through. It could be a string, character by character, list, of course. There's also anything you can loop through. There are many different other data types, tuples, right? But you end up with a list. So you have a new, so it does not affect, does not change original, right? So here, right, we are using a sort method for list in place, right? Means, what does it mean? Modifies the list. So this here, when I call this method, it's most likely it will modify. Of course, in this case, looks like the name matches how it was originally stored in a zip, in a folder. So it looks like there was no real change, right? So again, so to keep in mind is, again, if you're working with data sets, whether you are modifying something existing or whether you're returning a new set. And it might really depend. If you have a huge data set, maybe you want to sometimes with pandas, for example, you're working on a slice, but it's actually not a copy. It's actually same data, right? You're modifying something. You have like an alias to some subset of data. You're modifying that, but maybe you want to make a copy of it first. So usually many data structures will provide a copy method. So you can copy something and it makes a copy of the data, right? And again, why is this not always just one way or other way? Because again, depends on data size. If you have 1 billion items, you most likely don't want to keep copying it over and over, back and forth, right? It's going to get really slow, right? If possible, you want to modify in place for large data sets. For small data sets, auto place, right? It might be actually, for file lists, if it's not 100,000 items, right? It might be a good idea. Maybe you want to keep maybe 3 different data sets. By the way, I didn't show you about the variables. So if you are on a collab, right? There's a little X here, right? Those who are not used, variables, right? It tells you what's currently in the memory, right? There's some buffered writers, there's a hash mode, there's a zip POSIX path, there's a zip file, there's a list of XML files. It tells you how big it is, right? So it's pretty nice. If you are in Visual Studio Code, it's the same thing. Jupyter, here, tab, on. You should see your variables, right? You should see your variables. What's available, because we are connected to a Python kernel. Let's see if we can, here you go, right? So it's loading, it might take a while. You see I have different XML files. You can see, looks okay. Closed, you see it also tells you a zip file is already closed. It's still, the identifier is in memory, but it's closed, meaning you can safely, open up somewhere else, right? And there's a zip path, nothing very interesting here, right? There's a progress size, right, which is actually counting the progress, actually looks like chunk. I think you can use this to resume, right, resume the downloads, I believe. You can check, it will keep this size, how many you download, and you could resume it at some point. Okay, so what else? Oh yeah, and the chunk, it's the end of the zip file, actually, the last 700 bytes of the zip file. Okay, so yeah, this is going to be handy if you're working. Maybe maybe you forgot to run some cell, maybe you did something, especially if you keep running the same cell over and over, right? And then you might change something, and you see why doesn't it work? Oh, I overwrote something, right? So this can be handy, I believe. It's again, I use it from time to time. Of course, you could just do print and something, or check what it is. But this is a nice extra thing. Okay, now I need to download, make it smaller, right? Okay. Now, so size, and let's print it. Let's print 5 largest files on their respective sizes, right? So for file in XML service files. So let's check this out. So again, why does this work? Because this is a path of, because this is not a string, you see here. This is a list of paths, right? Path is a special object in Python. So it has some extra properties, some attributes. So it has statistics, right? And statistics has extra properties, in this case size, in integer size, right? Standard. So let's check. So these are bytes, right? Size in bytes. So last 5, so it was sorted ascending, right? Of course, you could have reversed. You could have a reverse flag. I could have, say, from the biggest. So these are, so here these were largest size ascending. If I wanted, I could reverse it. So what's the trick for reversing a list or a string? Who knows? -1. Yes, yes, very good, very good. Right, so that's a very good trick to know. Right, if I wanted the reverse, I could do it here. For example, easy. Just do this, right? And it will reverse. So it takes a slice of last 5, but I will start with the largest one first, right? So I reverse it. So I reverse. Yeah. So I took the last files, took last 5 files and reversed those. Yeah. Again, slices will give you, in general, will give you a new list, right? So this is a new list, and I reversed again. So getting the same new list again. But again, I'm not using it here. Speaking for larger data size, for iterating, I'll make a note here. For iterating, looping through larger collections, I don't know, maybe 100,000, reversed would have been, because it does not load everything to memory. That's something, again, keeping some extra optimizations. But of course, here we have only 5 files. This is just fine, right? So now, so we see it reversed, right? So this trick is good to know. -1, it returns you your collection in a reverse order. Also good for reversing a string reverse, right? Okay, so are you with me so far? Okay. All right, so we finally now we have the files. So now we come to the moment when we want to look what in the world do we have, right? Okay. And let's take a look. And here I will use Visual Studio Code. Let's see how does Colab deal with this. Let me check our file structure. OBC text, right? Let me check the first. I wonder how well it supports this. So I'll open up here. It's a big file, about 300, not big. It downloads, it's too big for opening. Let's see, can we do anything else? No, it does not offer any options for editing. Unfortunately, if it was smaller, possibly yes. Some text files, some CSV files, it does have built-in CSV support, right? So here, those with the local, so you could open up with the Notepad++, that's a good editor for opening up, but I have a Visual Studio Code, so I will use that, right? So let's take a look, not data, but temp, right? Where's my temp? Where's my temp here? Okay, OBC, so notebooks, temp, OBC texts. So I'll open up the first one, right? So we end up with the XML, right? So what's an XML? Again, this will help you also with your web scraping thing, web scraping workshop, is that it is somewhat similar to HTML. Why is it similar? They sort of have the same grandmother or grandfather, basically. It's an old standard from 1980s, actually, idea of having these tags, right? It's a hierarchical format, right? You can have nesting, you can have tag within tag within tag, right? So it's a good way of storing information in a non-linear, non-tabular format. The bad news about this is we humans don't really deal well with this type of multiple levels of nesting, right? Once you start going deep, right, it's kind of hard. So, and in this particular XML, it's actually following a TEI.2 standard, right? A text encoding initiative standard. This is something I'm sure if you're working with text analysis, you will run into. So what is it? Let's talk about this. What is this standard here, right? So, So Text Encoding Initiative, right? It's a consortium that has basically guidelines how should text be represented in a digital form, right? So basically they provide you a documentation how it should work. I will open up a link here. I want to open up the Control-C. Right, I'll open up a link. They see, right? I'm sure some of you have used this, right? Some dealt with this. It's basically just says, okay, what's a good idea? How should you pass these corpus, these textual data? How it should be encoded? Because you inevitably have some metadata about it, right? And gives you some basics, so guidelines, right? Current guidelines, default text structure gives you some what should be in your in this document, right? So there should be a tag. So how does XML work? You have an opening tag generally, and you need to close it, whether it's self-closing or you have a closing tag, right? And inside you have a nesting structure. I give a link here to if you need a tutorial. This is not official tutorial. This is W3 Schools, which is not maybe the best one, but gives you nice. Where is it? I didn't press it. Oh, here you go. Right. This is not official W3C consortium, but it gives you an idea basically, right? This is just generic, right? Nothing to do with stay. How XML works, right? You have a mention what is XML, and a note closes, and you have some tags inside. In early 2000s, there was idea that XML and HTML would kind of merge together. You use XML for everything, basically. There was even a time when there was idea of XML for databases. XML would be everywhere. Well, again, it turns out we humans are not so good at reading XML, and most people we don't want to deal with it too much. Unfortunately, of course, data. As far as computers go, it's a nice format for parsing data. So we are sort of stuck with it still, right? You'll see quite a bit of XML in various incantations around, various versions, right? Right. And what makes it actually complicated, that within a single XML file, you can have multiple namespace. What's namespace? Meaning, let's say I make up my own XML for my own type of markup language, right? And somebody else is also using it. Maybe library has its own standard, maybe something else. On one document, you have multiple these standards inside, right? And this makes it's nice theoretically, but practically it makes it really hard to parse, to get the information out. Because you might have a same tag, maybe body tag, or maybe paragraph tag, or I don't know, div tag, but it might have different meaning depending on the namespace, whoever made the standard, right? So that is really adds extra complexity. So what we are going to be using, since XML, right, we're going to be using for now built-in tools, right? So I'm using something called element tree. This is part of standard library in Python, right? Python is good for that actually, for parsing pretty much most formats, right? So I will use a XML E3 element tree parser, right? So notice what happened is I imported element 3 as ET, right? It's also a very common abbreviation. Let's go to installation, downloading, general considerations. Where is my first code? Let me see. Web pages. Oh, downloading. Here you go. There's data collection. And so I imported, you see here, right? I imported this element 3. It's actually part of a larger module for all kinds of XML support. But for now, I only need the element 3, right? Lightweight XML support, right? So again, XML is naturally suited to this tree format. You have some sort of top-level tag, right? And you have children inside. Maybe they have sub-children, grandchildren and great-grandchildren, and so on and so on and so on, right? So tree format is kind of natural. And again, so we have, we'll try to avoid using any external libraries. We'll use this built-in element tree, right? Sometimes it does not work with some types of XMLs, right? But in general, it's pretty good. better than most other languages, right? So pretty good for parsing. So let me go back to, where are we here? Te. I'll click here, right? So here what I'm doing is, I said, so I have a file. I'm going to parse this file. So my first file, right, equals what? XML files, right? Open and parse the following file, right? Right? So that's the file I'm going to open. I have my full path, right? On here I just skip the part where I made it a new variable. I just basically put the first file, right? Right. So indexing 0, based indexing, of course, in Python, right? So I parse it. And of course, this assumes this is a valid, of course, assumption. The big assumption is that it is a valid XML file, right? If you get an exception or error, it means it was not quite XML file. For example, if you're using Visual Studio Code, let me try to break something here. If I do this, let's see, right? Bad, right? So this breaks, it does have a built-in parser, so Visual Studio Code will warn you if you make a mistake. In fact, even I have my copilot actually tells me how to fix it, right? So let's see if I can break it like this. Yeah. You see, it remembers, and I can fix it back, right? So, Control Z, I don't want to break it. Yeah, I'm back to original. Yeah, Tate dot. Right, so you see how this is a start. If you go, this is 300 kilobytes. They're pretty big. I can use this mini map, right? I can go back, and you can see how end of it is mostly closing tags, right? These are all closing tags. You close so the last one to close is the first one to open. Right? Makes sense, I hope. Right? So, now this starts our investigative work. What do we want to get out of this? We want to get the text. Primarily, in fact, this XML file has done some work of markup, actually has some structure. So this is, I would say, semi-structured or already structured, but maybe not for our purposes. It has its own tags, right? Some meta tags, right? So our purpose for this workshop will be to tells you where it is created to get these trials, the meat of the document, which will be the transcripts of these trials. So let's see how can we find them. So basically, how do you find them? The best way is to do it visually. Check, right? So do some investigation. So we have this div 0, and we have a div 1, right? Let's see what else we have. Let's see, we have proceedings like original. This is like 1720, so 18th century. There's recorded the people who were actually participating. Okay. And we could save these, but for now we'll just focus on the trial transcriptions because they will have the language. So, again, we have a lot of jurors. These are all juror names. Those would be also interesting to see if you are analyzing jurors. But we want the actual transcriptions. So here we go. So this looks like what we want. Div 1, apparently they came up with a tag div 1 because apparently they didn't want to conflict with the regular divs, which are used often for other purposes. So it's like so div in general, when you do your web scraping, it's just a generic container. It's a tag for anything, but inside, can you see this, right? You have some attributes. ID, for us, it's not really particularly interesting. You have a type, it's a trial account. That's interesting because it lets us use some filtering to check only trial account because div 1, this is trial account, but I think here we had somewhere div 1. There's another div for the jurors. It's also used div 1. So they are reusing these tags. So we want a trial account. And you also have n value, which means probably numbering, right? And then you have some tags, which also gives you lots of extra information. And then you have what you want, actually, is you have some text inside, right? And that's what you want. Looks like somebody, the first case is somebody stole 70 pounds of tobacco. Quite a lot, actually, right? Yeah, Joe Wicks. No, that's a victim. I can't. There's no name actually, but interestingly, this is missing the name of who the criminal was, right? And he is guilty on The punishment in those days was transportation primarily. I think it was basically you were transported, I don't know, to Australia, no, but probably to some sort of war camp or something, right? I know who have studied 18th century England, right, might be able to provide more information. Okay, so, but the whole thing what we want is we want to get a div, right? So let's see how many of these div tags we have, right? So we have so we started the root. We have the root document. We want to, again, this will apply to any XML, not only TE. So if you're working with XMLs, this should prove helpful. And we printed, so I printed the root tag is TE2, right? And again, this would be your first, you know it's an XML, and right? So, okay, so we now first see what TE is, right? And again, the problem, of course, with these standards is that nobody follows them exactly. There's a lot of variations with these standards, right? So, again, so we have so we use any standard text editor, like I use Visual Studio Code here, right, to check. So I will be getting div once on the root, right? The root is an element, right? XML element. So it has methods. Methods are things you can do with it, right? Basically, they are functions attached to the object, right? So I will be using very kind of fancy way, but I think you can follow what I'm doing. I'll be using the syntax I'm saying is I want find me any elements which are called div1, but also in the same query, I want the type of trial account, right? Because that's what I have, right? I don't want the jurors, I don't want anything else, right? And I'm using, of course, I'm using what? I'm using list comprehensions, right? Because I'm basically, this is going to give me, it's going to give me a generator probably. No, it's going to give me a list actually, so not even a generator. But, so I could probably, I wonder if I could, maybe I could do it without these actually, right? Let's see. Okay, let me run this first. It should be 75, right? Let's try it. And I did not, root, I didn't run it. What happened here? I thought I did run it. What happened here? Root? No, I did run it. So did I miss something here? Some value? Root. Okay, yeah, it worked fine. Yeah. Basically, I think I got not refreshed it, but I could have swore I did run it before, right? Maybe it was did not parse it correctly, but if it gives you a root tag, it should be. So if you're getting this root tag, it should be ready to work, right? Yeah. Sometimes just rerunning things works fine. Yeah, you have root tag, and now. Yeah, see. Yeah. So now, so we can check, of course, what kind of variables we have. Let's check what we have here. Okay. Oh, sorry. I need, so I could really use two. I sometimes work with two monitors, right? You could split things. So yeah, let's check what we have. So the 3 is element 3. So it should be available. Again, it might be, and also I have root. I have the 3 and I have the root element. It's an element, right? Just one element. And actually it tells you what it is. It's TE2, right? Somewhere in memory, right? So looks okay. How about those on Google? It works? Works, okay. Right. So again, if this looks kind of, fancy, very compressed, right? But because I'm using some things here, I'm using so-called XPath syntax, right? It's a very powerful way of accessing XML on HTML elements, right? But of course, it's a little bit terse, right? So I'll show you how you could do it without it, right? If you want, you can check the syntax refresher, but I can show you how you can do it without any of this fancy stuff. So when you do this trial accounts, a fresh loop, right? Standard recipe. So we basically say, find me any div1 tags. I don't care what they are. And I check, does it have a type, right? Because it's quite possible in general, right? Maybe, right? You cannot make assumptions about this, any type of this structured, semi-structured and structured test. Maybe there isn't type, right? It's possible, right? And maybe it doesn't have trial account. Maybe it's different. So we don't want that, right? So we have two things we have to check. We have to check whether there is a type in attributes, right? In this this tag, whether it has actually a type, and whether this type is actually trial account, right? And if it is, if it meets these two conditions, and of course order is important, then we can safely append trial accounts to this list. We can use append, right? And we should have 75. Again, let's see if it works. Yeah, it works, 75 again. So again, I'm not going to check for, so did it work for you? Right, so this simpler recipe. Again, of course, it depends if you have, so this is an element. So elements have attributes, right, property. It's a dictionary of attributes, and you can check whether it actually, there is one, whether there is type in attributes, right? And so this is actually a dictionary of attributes, right? So we have a list, right? We are going to a list, making a list, and we're checking a dictionary whether it exists and if it's actually trial account. We could use probably get here as well. If get alternatively, right? Let's do one more. We could use the get method because in dictionaries have a get method. Let's try it one more time. A code. I will add all this code later. Afterwards, you'll be able to check it. So we could use get method for the attribute. Yeah. Yeah. So trial accounts 3, right? Right, same thing. So for D1, okay, and my looks like Copilot is slowly, so I'll have to do it by hand. That's okay. So iter, right? Again, I didn't provide enough context, right? So on if, let's see if this works. If div1 attrib, yeah. So that's what I'm going to say, right? So what I am asking, checking whether there is a type attribute in our XML element and whether it is actually trial account. So I can do this in one line. We can do it like in a two-way, checking it one by one, where order is important, or I can use the get, which is provided to all the dictionary types, and you can get the value. And I check also, I might get none, which is fine. You know, I check if it's none, and it's trial account. We check if it's not, then I don't add it. I don't add it to the trial accounts. So this might be an alternative. Is it speedier? No, it's going to be roughly the same speed. Actually, maybe slightly slower than this approach, right? And it should be, if everything goes correctly, we should have the same number, 75 trial accounts, right? Let's check on trial accounts 3. Yeah, 75. Okay, so now we have 75 elements of our trials, and we can try to extract the text, right? So again, reminder, it is using the stay format, and there's lots of meta information here. For now, we are skipping this. We just want to see who was stealing what from whom, basically, right? And what the punishment was, maybe, right? Right. So, yes, sure. Okay, great question. Okay, so idea is this. If you remember get is a method of any dictionary. What's a dictionary? Dictionary is a key value store, right? You have a unique key, you get value. Why do we use it? Because we have instant access. Even if you have billion items in dictionary, you will get access to the values instantly, right? So it gets tiresome checking. I wonder actually, by the way, so get takes two parameters, right? It gets what kind of key you are checking, right? And actually, I think here this would be actually optional because by default it gives you none. So this second parameter is what do you return if there is no key. So if there's no type, you can return anything. You can return Valdis, you can return Baltic School of Summer Humanities, you can return none. I believe that none is actually the default. So this is the part where we get actually, this should work as well, right? Because, let's check it again. Yeah, it also works because none is actually default. Is actually the default for get. Right. In our case, for get, yeah. So again, so get is basically, instead of writing 2 ifs, you write 1. You save 1 line of code, right? Again, if you're working with dictionaries, get method might be preferable. If you need to if you know, of course, if you know that key exists for sure, this is going to be faster, right? If you know there is guaranteed type key, right? This is going to be faster. So get is slower. Why is it slower? Because it's using this check, right? So basically, it's writing your code underneath this get. There's an if. It's checking whether there is a type key, right? And then you check actually whether the value associated with this key is trial account. Okay, so we have 75 documents. Well, elements actually, XML elements, right? Encoded in the state standard. We want to get the text out, right? Also, I would like to get actually some maybe a little bit, tiny bit of meta information, maybe a little bit, right? So let's see how it works. So this is my first attempt, and this won't work actually, right? So why doesn't it work? Right? It's empty, right? So I get text attribute, right? But notice if you read this documentation, always pay attention to the documentation if something doesn't work. Text before first sub-element. So that's, let's check our XML. What do we have? Do we have any text? No, we don't. You see, we have some sub-elements. So, or it's no surprise. There's no text because the text, well, it just doesn't work. This method does not work, or this attribute does not work. It's not going to give me any text, but what I want this off. I want this indiction. I want this tobacco, this 70 pounds of tobacco, right? I want the text, okay? So I'll need a different approach, right? So it turns out what I can do is I can use an iterate method. So I have my trial accounts, first account, right? So again, I'm using list comprehension, right? So I go over all the text fragments, basically. And again, it's a generator, so it's not a list. So again, I'll need to convert it. So it's going to give me these little pieces of text, right? So what I'm going to do is I'm going to join them together, and I'm going to join them together with a space. So who knows how join works, right? You have a collection of strings, and you provide some way of some character which would join the text together, right? So question is, why am I using space here? Yes, very good, very good. Otherwise, it's possible I have like, I don't know, Riga and Baltic, and it will be together, right? So I want a space. Afterwards, I will have to clean it up, but for now, space is a safe choice. Okay, so let's see if this works. And it works, except, of course, I have a lot of empty space, and unfortunately, again, my Grammatas 500 internet connection is kind of slowing down. Right, so job Wix looks like there is everything, all the text is here, so that's good news. Then only thing is what we'll have to do is we'll need to clean it up, right, to remove some white space and get started with that. So, yeah, I tried punish. And yeah, let's see, can we find some other things? So I mentioned I want to find some extra things. I noticed, again, many of these things are very specific, right? I have the extras like types. These namings are kind of specific. But what I did find is I find defendant punishment, right? So there's a join tag, or actually I think it's RS. There's RS actually. Yeah, no, here's RS. Whatever the RS tag is, I don't want to look, I could look it up in a TEI. It's probably from a TEI, right? So, but here's a type punishment description. I could probably use that to get some metadata, whatever the punishment is, right? So getting a little structure separately. So I will save the whole text, but also I'll have the way of punishment. And my assumption is that not everybody was guilty, I hope, right? So hopefully those who are not guilty, they get no punishment. I assume it's going to be empty, right? So let's see that. Okay. Now, so again, we use the same idea, and it doesn't quite work for let's say RS. Let's see. And yeah, it's Polish. It's RS element. On transportation. And there it is. So I'll need to clean it up, right? So And finally, how about the year? We also want to save the year wherever this trial took place. For that, I didn't spend too much time on the time. It's probably somewhere here. I mean, but we see it's nicely organized by this part here. So I will infer this information from the file name itself, right? And I'll show you how you can do that, right? Again, one way of doing it, I have a name. So XML files, right? It contains these path objects, right? And they have name property, the file name. So what I will do, one approach is knowing certainly looks like it. It looks like it's using this approach. Where are they? Like this, some text, dash, and some more text. So what I want, the year will be here, the first 4 characters, right? I'll have to convert it to number after the dash. So how could I do it? I could, without regular expressions. Let's do this without regular expressions for now. I split it. So first file name, the first one, name, property, split by dash, right? And I take the second. So I take second. Okay. Oh, what's happening? That is not good. Oh, you lost me or I lost you? Luckily, I'm still recording. So let's see what happens now. While we're storing the screen. Maybe the connection. Let's see, how can we get back to it? Okay. Maybe after the next break, I'll try to have to go to conference Wi-Fi. It looks like a better option. All right, so let's see. It's okay. Now we are back. Can I? All right. Can you try seeing if the screen is or? Yeah, maybe I wonder if during the break we can get the cable here. That also might be an option. That might be faster. Okay. Right, so. Jā. Tad ko man iziet ārā vispār leju? Līdz, tad būs vienkārši meeting. Okay, update. Okay, now. Let me try again. So you can see me, of course. Now, of course, I'll need to connect again. And I don't know, remember that. Let me see. I have 3. You see the screen. Wait, wait, so you see the screen. Because it's I'm on my HDMI, right? That has nothing to do with Zoom, right? Because I'm not in Zoom right now. Pretty sure. No. But Zoom is not connecting. What's happening with this conference? So how do I get to conference? This is certainly better connection, conference.
Actually, I'm seeing you on Zoom.
Yeah, you are seeing me? I'm still in Zoom?
Yes.
Oh, maybe I'm not quite off then. Okay, let me see here.
Yeah, and Zoom people also can see and hear you.
Okay, that's good. Let me see what's happening with properties. Chrome, OBS Studio, Zoom. I don't see Zoom here. That's interesting.
I'm streaming you on Zoom.
Okay, so does it work right now? So you see the screen?
It's fine, you can keep.
I can keep working? Okay. So, okay, great. All right, because of course I have the feed, of course, the video feed. And okay, great. So, that's perfect. So,
On Zoom, we are seeing you.
Yeah.
We are not seeing the code.
okay, you do need to see the code, right?
You must see that. Yes, we see.
Okay, perfect. Okay, so super. All right. Don't worry about me. Look at the code. All right, so That might save us maybe some bandwidth. All right, so we have, so the idea is to get the year. And again, it's not a complicated code. So what I do is I take a split by dash, and I take the second element, right? And I take the first 4 characters of the second, whatever the second split is. Of course, this requires that there is a dash in my file name, right? That's kind of obvious, but still, right? So that's one way of doing it, right? I'll show you, if you like regular expressions, sometimes they're very, very powerful, you could do the same thing with regular expressions. It's actually, in this case, regular expression is not so hard. So actually, the problem with regular expressions is, how, as the joke goes, if you know regular expressions for some problem, then you have 2 problems, basically, right? Because you want to do something really fancy. But yes, there's a website. I use regex 101. Where is it? I thought I mentioned here. There is a website, regex 101. You can test these regular expressions. Here, basically, I'm saying is I want to find 4 digits. So any number from 0 to 9, right, in a row. So in this, it just so happens that the first match will be the year. That's what I want, right? If I needed something at the end, I had to be more creative. So in this case, the first match in this text will be the first 4 digits will be the year, right? So very simple again. And of course, what I'm doing is I'm converting, since these are going to be characters, but I want the year as a number, right? So I want to convert to integer, right? And it should work. Looks like, again, I only have 20 files. I can check, right? So it could happen like you have like 500 files, and maybe 3 of them it won't work, basically, right? You can see, get an exception, check, you know, it could happen, right? So let's try it again. So both approach. So in this case, I overwrote it. So both approach works the same way, right? I advise this approach is simpler, right? You don't have to write extra regular expressions, but sometimes for something complex, this might be more powerful way. So we do a regular this is a standard library in Python for regular expressions, right? And we search and we find the first match, right? Group. There's a way of doing a parenthesis here. You can match multiple groups inside the regular expression, right? But again, I'm not going to go into it right now. So we have the year. How about one more piece of meta information? How about the trial account? That should be easy. Well, we have trial accounts, and here I'm going to cheat a little bit. Well, I know the first one has attribute, right? The first one did have it, right? Where is it? By the way, I could close this one. Let me close this. In a good text editor, you can close the tags, meaning you can minimize them. Let's see, these jurors, can I do this here? No. Where are the person name, paragraph? Can I close this? No. I don't see even close. Okay, maybe it's not. I'll have to just, maybe, can you make a bookmarks maybe? Because again, it's 300 kilobytes. These are all the alias. Okay, here you go. Oh no, this is only a case. Or maybe I'm too deep. Control home, right? Let's start over. Doc. And we want the first case. Lots of jurors. So, you see, it has an n. It has a property n. And the value is 1. Okay, let's get that out. And that's simple enough. Should be trial number 1, right? Attribute, and we know it exists, right? So now with this knowledge, right? So usually with dealing some problem where a lot of similar things to do, you try to get it working on one particular element, right? In this case, it's an XML element, but it could be a JSON, it could be something else. So by playing around, by trying, and then I convert this knowledge to a function. So I'll make a function for getting a file name. So again, assumption being that it has of course, minus, dash inside, right? So in this case, I will add an extra check. Sometimes it's possible I'm not getting actually the name as a string, right? I'm getting a pass object. So I check is this actually a pass or maybe possibly it's string? I'm skipping this checking of string, but I'm checking the pass. If it is a pass, then I don't need the full pass. I just want the file name. So I'm overwriting it locally for the time being, this file name with the actual name property, right? And then it's a string, and I can do my string thing. Yes, question?
Why are we checking it? Why is it possible that it could be a path?
Because remember, we used the globe, right? Our globe returns a generator of pass objects, right? Different paths, right? Again, what's different paths? Basically has some extra things, like has the ability to find the file name, the suffix, the parent mapping, has all kinds of different goodies, right? So it's not a string, certainly, right? So I'm checking it. So it came up when I was doing actually, I think, strings of the files, just the names, right? If you are sure it's a string, right, then it's no problem. Now, but this shows you how you can check if you need to check for particular data type, because Python is loose, very liberal, meaning it takes any kind of, when you're passing around variables, it doesn't check what you're giving it, right? There are languages which are strongly statically typed, which you need to say, okay, this is a list, this is an integer, this don't take anything else. Throw errors. Python says, takes anything, and errors only appear when you try to do something which is not possible to do, right? Again, it's both a positive and negative. Positive is it's very easy to write code, right? But checking sometimes for some specific types, right, for larger projects, right, it makes your life harder, right? Because if you find a bug, right, you need to see, okay, is this most likely? It probably has to do with some wrong data type, right? And this makes your debugging hard, right, for larger projects. So here, of course, I needed to have a check. And if it's a pass, I know I just need I can easily fix. So here I can fix this, right? If it's a pass, I know I just need the name, right? Next one, probably here I could have. By the way, this attribute is fine, right? What would be an alternative? Let me try to fix this a little bit, right? Again, because this makes assumption. This makes assumption that. That attribute has how could we fix this? Remember we talked about get, right? We could fix this. I would say I'll comment this out, right? I'll fix it up a little bit, right? So instead, safer would be yes, exactly, get method. So what could be a trial number if there's no trial number? We could use -1, we could use 0, I'll use 0, right? So let's do this. So let's use, it's using empty string, but I'll say, but I think it returns, how about 0 like this? Why 0 as a string? Because it's not a number, right? Because here, these are all, it's a string, right? It's not a number one, it's a string, right? So probably we'll have to convert afterwards to number, right? So you want to, when you provide the default value in general, you want to provide the same type of data. It makes things easier to debug, right? If you are returning apples, let's say, well, apples and orange might be okay, but apples and I don't know, airplanes, is not going to be okay, right? It's going to make things harder, right? So this, in this case, is not going to make difference because I can tell you ahead of time, all the trials do have numbers, right? But just in case, get will be safer. All right, now we want to get the punishment, right? We want to get punishment, and again, we check, right? And again, in this case, it's possible there is no punishment description at all, right? So what we do is this find method, right? If it returns nothing, we return empty string. Otherwise, we get whatever text is inside for punishment. Okay? Now, we make a method to get text from a tag. Again, might be useful for this. Again, it works for any XML using this ET element 3. And finally, this is already second lecture, which we want to talk about cleaning text, we might want to actually do some pre-processing or processing. So what are we going to do? You notice there's a lot of empty space, right? Because this had some extra elements which had nothing in them, some white space. So what can we do? We have some built-in methods for text processing. Strip, what does strip do? It takes from both sides, removes all white space, includes new lines, tab, white space, there's like 4 or 5 different types of characters. Then, actually, replace and strip. So, you say it removes new lines. Why do we need this? Because we might have new lines in middle of text, right? And then again, the same question we already answered is, so why do I not replace with nothing? Because, again, if you have a word ending something, a next line, right, we want the space. We don't want a new line. We don't want to put nothing because we'll have the words will combine, and that's what we don't want that, right? So, same thing for tabulator, and also this is also another thing with Windows. Windows, sometimes the encoding is for new lines actually has 2 characters. It has a line return and a new line, right? This also causes problems. Again, if you go back and forth from Windows to Mac and back vice versa, you may end up with these extra characters sometimes. Okay, so these are just things you can do, right? Yes, we get that. Yeah, that also be good. So you probably what you want to do is, so I'm chaining these methods. So I should do it at the end, right? Because I will end up, inevitably, with some, yeah. So this is a great idea. In fact, I do this later in the book. So yeah, this is replace at end. Yeah, it is, you see, machine, AI thinks like you do, right? So it offered me the suggestion already, right? So I'm using Copilot, right? So it knows the workflow that 2 spaces at the end of it, right? So we start with a string. We keep doing things to it because this returns text. And when I say text string, returns text, so we can keep working on it, right? I could have used a temporary variable, but it would take I have to write like 8 lines or 8 rows, right? So this takes very convenient. Because we have to remember in Python, strings are immutable. You cannot change string itself, right? You can just make you can make a new string, right? You can keep making new strings, right? So they are immutable objects, which is kind of actually nice. So now, one more function, right? So now I'm going to combine. So I have all these little functions, right? So my idea is this. For each trial, I want to make a dictionary of the data I want. Okay. I can get a year from file name, get year file name, okay. A trial number, I can get from a div. So here, punishment and text, I will get some text out, and I will pass it to the clean text function to do some more work, and then I will have some clean text already, right? So I do 2 things at once. Well, actually, technically 8 things, but the idea of making function is we make an abstraction. I don't really have to look. I don't have to look at these functions. I don't know. I don't have to care. I don't have to care that it cleans text. Maybe I did it should work. I mean, if I need to, I can check, is it cleaning properly? But I'm dividing my problem in multiple, divide and conquer, right? I don't have to worry about the cleaning text right now. I just have this function. If it's not working properly, I can go out and check, okay, if I'm doing correctly, I have some text. It's pretty simple to debug. Okay, it's just taking some text and replacing some things. Maybe I'm not replacing enough. Maybe I need some more things, right? Maybe I need another function. I could add another extra clean text function, maybe, right? Separate these tasks. Okay, so idea is to return. We have some keys of what we are returning. This is going to be, meta information and the actual information. Text is what we really want. Why am I using dictionary? You will see, because I will be building a list of dictionaries, and that's a very handy structure to pass to pandas, right? And we can have a nice table of all our data. That's what we hopefully will get to that. Right, so, and now before I go to start do everything, let me check a test. Let's do a first one, right? So, trial accounts and name for the files. Let's check it out. Let's see. Did it work? Yeah, it worked. Looks like year 1720, okay. Trial number 1, punishment is transportation. And here's the text, right? It looks like the first trial is missing, actually, whoever the guilty guy was. We just know where he lived. Maybe he was anonymous, I don't know. He didn't give out his name. So now we get to the key part of the programming. We know how to do one element. If we know how to do one, we can do every element, right? So let's do generalize this, right? So I'm going to make a function which is going to take advantage of all the knowledge that we just assembled together. So I know how to extract trial data from a single element, right? However, I'm going to make a function which will return a list of these dictionaries by going through each element, right, in my list and performing this work. And of course, the file name here stays the same, right, because they're all part of one file, right? So let's check. Let's check all the data. We'll get all the data together. Can you see this, right? And I have 75 trials, of course. Again, my trial data. So it is in a list of dictionaries, right? On my first file, trials punishment, looks like it was transportation was very popular these days. I was checking, people were stealing not only tobacco, but stealing also just the handkerchiefs, right, or some, I don't know, some scarves, some very tiny things, and they were getting some serious punishment for stealing a single piece of clothing, because of course it's 1720, and clothing was quite expensive, especially if it's silk, right? So again, plenty of things to explore. Now we know how to get our data from a single file. And again, if we know how to get it from one file, we should be no problem to get it from all the files, right? So again, we start with a very specific small case and we build up to the whole data set. And our data set is in multiple files. So let's make a function that takes a file name and we'll combine. First, okay, so not quite. So we'll combine all of these two parts. We just give a file name and we'll combine all the knowledge we did. It will check, get the tree, get the root element, and find all the D1 elements, and it finds all the trial accounts, and then it gets the list of trial data from the file name, right? So now it should be exactly the same, right? 75, right? So it looks like it works. Yeah, 75 looks good. So now, finally, we can pass a file name list, right? List of file names. Look, and make a function. Get all trial data from a list. So this, we just need a list of file names. We make a new empty list of our data. And then what we do is we go through all the file names. Again, TQDM is just a progress meter, just purely cosmetic. And it should be very fast because I only have 20 files. If I had 500 files, it might be important to see, whether you can go for coffee or not, right? So extend. And so what does extend do? Extend it's a list method. You have a list, right? And it extends it adds the other list flatly, right? So it's an in-place method. So it combines two lists, basically, the original list, right, with some list. And I know I'm getting a list here, right? Well, I know actually, in fact, Visual Studio Code is telling me I'm getting a list, right? It knows. It's smart enough to know, right? Even though I didn't tell it. It's actually a list of dictionaries of string unknown. Of course, unknown is going to be whatever values, but keys are all, it's actually pretty smart here. So I can safely extend, right? Because extend needs an iterable, right? It needs some sort of collection. So list would be one of them, right? So now we're almost done. So basically, yes.
So I trust you that we have to use extend, but what if we were using append?
Okay, append, here I'll show you append. Why I didn't use append? Because append it will take, if you did append, you end up with a two-dimensional structure. I'll show you the idea here in a moment. Yeah, here, right? So, so if we do append, right? Says we start with empty list. I'll show you. This is why use extend instead of append. Great question. So append adds one element to the list, right? So let's say my list, right? My list, right, is, let's say 1, 2, 3, 4, right? So I'll show you a difference, right? Another list, right? Let me see if it gives me something. I don't know, 4, 5. Come on, yeah, okay, right. So I'll show you difference, right? So append another list, print, right? You see the difference? You see the append is, it's nested. That's why I don't use append. It gives you, so this is 1, 2, 3, and this is next element as a whole thing, right? So you end up with a two-dimensional list. It might be something you need, but not in this case, right? So instead I want a flat one. If I want flat, do this extend, right? No, my list, extend, right? And again, another list, right? So, you see now? So I have flat, just single element nested, like matryoshka, right? And I have 4 more elements flatly. So I want extend in this case, right? Right. I'll show you, we have a few minutes, I can show you another way of doing it, basically. We could also do, instead of extend append, if it makes alternative would be syntax would be plus equal, right? So, like I could do this, right? Works similarly to extend, yeah. But I do it. So let's see here. See? Again, I extended it, right? There's some technical difference between these two, but extend, append. So in this case, extend is the appropriate choice, right? So hopefully you can see the difference. Yeah, super. All right. So we getting ready for all trial data, and I will. So I have a function. I have the XML files. Remember, I had the XML files. I can check. Of course, if I am not quite sure, I could make a new line. But let me check XML files. 20 of them, right? I have 20 files. Okay. So let's do it. How many will we have data? Let's see. Should be about 1600. Let's do it. Should be pretty quick. Yeah, it did 14 iterations a second, so took like 2 seconds. So what I did is, looks okay. You should also be getting 1637, right? And then what I did is I use a random seed to get some random sample, but it's not truly random. It's specific for this specific seed, right? So why do I use it? Because so you can see it gets the same sample each time. So I sort of like preloaded my dice, right? I said, okay, I have my hand in this position exact, and I'm going to throw the dice, and so I'll have exactly these 5 random samples. But I do this usually for testing purposes, right? That you're getting the same ones, right? This is just an example how to get some trial data, right? And again, I'm using it to unroll it, right? So you can see all these selections. Looks like there was even some serious punishment, transportation. So it looks like we also have some few people who got free. At least there's no punishment. So I assume they were let go, I hope, right? So hopefully they're not guilty, at least I hope, right? So there were also some bad things happening too. So let's check again, right? So if I run it again, it should be exactly the same. Yeah, it is exactly the same. I wonder about you, is this going to work same? Or is it going to be window Python specific? I wonder. Do you get the same cases? I wonder. Sampling? Yeah? Okay. So it does work same. Okay. So now we have a few more minutes. Let's save this data. So we're going to use pandas. That's why I did it. So I have a list of dictionaries. So what's going to happen? The column names, right? We humans work very well with tabular format, right? Tables, Excel, spreadsheets. So pandas is a natural extension. it's basically Excel on steroids, right? We want to, so we're going to have a column year, trial number, punishment, and the text, right? And it will work automatically because we have the dictionary, right? Each entry in our list is one row, right? And so automatically pandas will see, okay, what keys are you using, and it will make up column values for that. So let's do it. And did I do it or not? Yet. So looks like it. So again, shape looks okay, 1637, and four columns, right? Now the question is how to save it, right? We can use the path again, right? And I want to say I'll save it in a temp for now. Again, of course, if you want to save somewhere else afterwards, you might want to download it, right? But for you, I already saved in a data folder. So in the next next section, we will be able to load it anyways, right? So this is CSV path. CSV is a handy format because it's human text format, right? But there's bad things about it too, right? Because there's no real hard set standard. It's sometimes might be again hard to read sometimes. So let me save it. And what I'll do is I will use index false because these numbers are not really needed, right? Sometimes if you forget about this index false, you end up with a lot of extra indexes you don't need if you're not paying attention, right? So also I will save to Parquet. Parquet is one of my personally like this format because it's basically it zips the file, compresses, and also it keeps the data types. That's what's very important, right? So for your data, you want to see, okay, is it like a string? Is it number? Right, it'll keep. So, but problem is sometimes the drivers might not work. It should work. I checked on Colab, it worked. Sometimes if you install the libraries not correctly, the Parquet format, it needs a separate import, separate pip install for pandas. So let's check if it works. Okay, these are the paths. And right, we'll have some extra discussion, but maybe we'll do that afterwards. Right, so we have saved the data, we gotten the data, and we're ready to work with data. Right, so and then next section we will be already uploading this, downloading this data from this Parquet or CSV format. We'll need to do some tokenization, some cleaning, extra cleaning, but we are making some good progress. So, any questions so far about this process? What's your favorite file format? Simple text, yeah. Simple text actually, yeah, because that's what you use all the time, and it's you get to make up your own rules what to do with it, right? It's easiest also to work with. Yeah. What's the least favorite? PDF, yeah, it's horrible, true. PDF is the most horrible format because first of all, it's extracting any data from it is really, really hard. So yeah, thank you, and I will stop the recording. I know that these lectures are recorded on our library system, but I also have my private recordings, which will be available on YouTube at some point. I will add those, so you'll have two ways of checking these out. All right, so I think we have a break. You can see my screen. Right, so we have finished this book, this first notebook, right? And in effect, in a process, we have obtained structured data. We have some metadata information, the year, the trial ID, the punishment, and of course we have the text. We have the plain text, right? And again, we save this as in two formats, as a CSV file and the Parquet file, which is basically a compressed file. If we had more time, maybe a third day would be necessary, we could work with some other formats because what's common? JSON is very common, also reading some other ones which are not hierarchical, right? But okay, so let's proceed to the second part. So I will open it up in my notebook here, and if you are working with Google Colab, for you just have to go and click the next link, right? It's very simple. So you just click the second link, preprocessing and preprocessing and processing data, which will basically deal with cleaning data. Right. And of course, I need to make a connection, right? So if you want to use Colab, right? So again, this part will cover all the tasks we need to do before we actually get to, embeddings, before to building any models. We want to prepare the data in some way. let's look at some of the techniques, right? So things, let me go to up top, right? So, we want to transform text into more digestible format, and also maybe there's things we want to remove. Again, for larger text, corpus collection of documents, there might be many things which are just extra fluff and are not really, just slowing us down. Because the algorithms which work with large data corpuses, of course, can get very slow, right? So what do we need this time? We need paths. Again, we need something to work with these file paths. We need a counter. This will be for counting things, right? It's basically a dictionary. I call it dictionary on steroids, or dictionary with benefits. It's just like a dictionary with some extra things to do on top, right? And string is for punctuation definition, and regular expressions might be useful. Datetime is just for data, for timestamps, right? Time for timestamps. And pandas, of course, pandas will need to work with pandas. Also, spacey will use sparingly for some lemmatization, some stop words, just a little bit of spacey. So, and it will be also one of the things we will maybe possibly have some roadblocks. Okay, so let's see how it works in okay, my disk size, okay. I have very little RAM. Okay, it's me, I'm gonna run it anyways. And we should have the imports. Let's compare the versions. At 1.53, 3.54, and we have 203 and 360. Right. Okay. Not too much difference. And now we will, since we already did all this work, it would be shame not to use it again, right? So we have the file. So if you go to the notebooks, let's open a notebooks data map, and we have a CSV file. This is the CSV file. If this is a smaller file, GitHub can view CSV files, but this is a little bit too big, 5 megabytes, right? So quite a bit bigger than the original file, zip, because it's not compressed, right? So about 5. It includes the plain text, right? So that's a link, right? That's a link, but for raw, this link is not going to be good for downloading. For downloading, you need the raw link, right? It's the same link which you will use by hand. So this link here, copy link address, right? So which would be, and I already copied for you, right here, URL. So here, instead of using this recipe, which we learned in the last lecture, we can let pandas do all the dirty work. And pandas is great. It includes requests functionality, right? We can use directly. So pandas read CSV. This is a mega method. I think it has like about 50 parameters. And there's a reason for that, because of course CSV is there's no specification for CSV. It just whoever comes up with some idea, they think it's a CSV file, because CSV is comma separated values, right? And there are many variations on this, right? And also maybe variations of what the index is, what the columns are, right? But the good part for you is in pandas, right? We have imported pandas. You just pass the URL, just like a file name. Very handy. So let's do it. And basically, we should get the original, the information which we saved from the last notebook. Let's try it. It should work. The shape looks okay. We see the punishment. Looks like a lot of transportation punishment in those first 5 cases at least, right? They're all guilty, right? And it looks like it worked, right? And we have, the only thing is, which I might not completely agree, the index column, we used 0. So basically, it's not unique. Usually you want to have a unique value. But pandas is kind of interesting because it has a dual indexing structure. It's using a string. It has a column, like a string indexing, but also has a numeric index as well. So you have 2 ways of accessing rows, right? So okay, but we'll keep that for time being. Yes, question?
So why does the shape say
because this is the index. Right, so what happened is here, okay, this is, I could have skipped this, right? Let me show you what happens if I skip it. Let me do it over. I will comment this out and I will skip this, right? And I'll read it again. You see 4. So now year is just a regular column and it has an index. The issue with this indexing is that this leads to a lot of unnecessary errors because it's like a numeric, it's a number-based index, right? 0, right? However, Pandas offers us 2 ways of accessing this index by, it has 2 different methods. It has by the key value here, right? By the index name and by the numeric value. And in this case, they are exactly the same, but the 2 methods, they work slightly differently. And so that way it's really hard without paying like really close attention which way of indexing you are using. So what does it lead to? It can lead to like off by 1 errors, meaning you might get maybe 1 too many or 1 too few. So my recommendation, if it's possible, is to use the index as something which is not numeric like this. Maybe it's a big ID. It could be like, I don't know, 5,600,000 something, or could maybe it could be a timestamp. Would be great, or maybe could have been here a user's name, right? We could have come up with some ID, but numeric index, it's really kind of it works 90% of the time, but when it doesn't work, it can lead to some hard to catch errors, right? Because you might be because of this dual indexing scheme, right? Because it's very convenient. You have 2 ways of indexing. You have basically, in Pandas, you have a way of accessing columns and rows by the order, by the index, first column, second column, third column, fourth column, right? But you also have a way of accessing columns by the name, year, trial number, punishment, and text. And same goes for the rows, right? So if they are exactly the same, unfortunately, they don't work exactly the same. But we'll see. Okay, I can keep it like this. See if will we have any problems? Let's check. Okay, will we see if we run into problems? Right now, I use index column nothing, right? So this means I have this generic index. Okay, do we need it? Let's see, can we get full text? Let's do some analysis now. The first recipe I'm going to show you is you have some text columns, but you want to get only it as a one big text, one big document. Why I'm doing it for full text? Because I'm going to do some textual analysis for just a character level, right? I'm going to treat it back to as a whole. So how do you do it? I'll use a join, again, using space for now, right? What I'll do is each of these columns will be a string. So I'm going to convert all these columns to string. You might be asking, wait, it looks like a string. Well, technically, this is a Pandas, so we can check that Pandas can provide you. Let's get information on the data frame, right? So info returns about data types. Data type. Yeah, let's check. Yeah, so it's using how much, not very much memory, actually, but that's not full memory. I think deep is true. Deep is true? I think deep is true. I think this was this it? No? I forget how it was, but so text is not actually a string, it's an object. It's a very generic term. It's what Pandas uses, and actually, this is one of the limitations of Pandas was that Pandas, of course, great for numbers, right? But for strings, well, it's not so okay, but it's really made some big improvements in this regard, especially version 2.0 on. Right, so they're not empty. So there's looks like every entry has something. That's actually good news. We don't have any missing data. We might have empty strings, but we don't have any completely missing values. Right, that's good. Right, of course, we could also we can do some describe, by the way. Also, a good thing to check is let's check our years on trial stats. Not very interesting, but let's check. So df describe will give so this is just basic statistics, right? So we know, of course, 1630. Well, mean is not very useful, but yeah, it says mean is 1823, minimum is 1720, which we knew, and maximum is 1913, right? And trial numbers, we see that there is some entries which had 170 trials. Minimum is 1 because, well, that's how we start counting the trials. The question is, what about these two other columns? You want to get some basic stats about punishment and text. Well, we can get statistics on non-numeric using O syntax. Yeah, include object, I think, right? I think it's O, not object. Well, let's try this. Yeah, so looks like the top punishment was transportation, and then there's attachment to see summary. So basically, yeah, they were transported somewhere 106 times. Again, here, of course, for text, it might be useful as like an extra check. We are checking whether there's any non-unique texts, right? In this case, as expected, all the texts are unique, right? Because, well, that's you expect it's a text description. You wouldn't expect exactly identical trial description, right? But it sometimes could happen, right? It might be a good extra check to check if there's something really strange going on with maybe some error. Maybe you see like there's exactly similar text of, like, say, 10 texts. It could be they're empty, or maybe they like have some sort of boilerplate, maybe, possibly, right? But here it looks like, well, they're unique texts. On punishment also certainly looks normal that there's a punishment. Looks okay, right? Again, now I want to do some preliminary analysis of the actual at the character level to see if we need any additional cleanup. On here, actually, we are in really good shape in general because we're dealing with English text, right? If you're dealing with Latvian, I don't know, Spanish, German, any other language text, you'll have more problems, actually. I'll tell you ahead of time, right? With English text, it's much easier to work because, first of all, for most part, they follow the regular ASCII conventions, and many, many tools are tailor-made for the English texts, right? If you deal with Latvian text, it'll be a little bit harder, but we'll see. But we'll touch on some of these sort of say details. So, what I'm doing is I take a list of all the texts in this text column, right? Convert them to strings. So I use the apply function, and then join them back together. So it's a big text. So I want to see how many letters do I have. So it should be a little bit smaller because we did some extra cleaning right now. Let's check. No, actually, same one, right? Because I don't think I saved it. So you can see that's a full text, right? Weight of felony and other sentence, 3 years penal servitude. So he stole 70 pounds of tobacco, and that's what he got, basically, looks like. Oh, no, that's the last. No, that's the last one. That was not for this was from this end of the text, last characters, right? So, okay. So now what I want to do is just look at the character level, and of course, symbol analysis. Of course, symbol is not really a simple term. It used to be symbol was just a byte in old days, right? And byte could mean many things depending on the language. Those who remember 90s and computers 90s, you use different encodings. The good news for us these days, we are using Unicode, right? We're using Unicode to encode pretty much all languages, including Chinese, Japanese, emojis, right? All under one code numeration. But the issue is, how do you save them, right? How do you encode this, right? Actually, it's a little bit tricky issue. Generally, if you're lucky, it's using UTF-8. Let me check, doesn't mention here. This was UTF-8. It's a default, I believe it mentions somewhere here. Let me see. Usually it mentions, yeah, it does mention that, right? The problem is, and this was we are lucky, that also it matches. However, sometimes the document will not say how it was encoded, right? And you can't really, the computer, if you don't tell it, right, it can get a wrong encoding, right? Sometimes it happens, especially with a language like Latvian, right? You might encounter some other encodings. Okay, but now, for now, what we're doing is, I mentioned the counter. This is a built-in. It's basically, it gives you a dictionary object with some extra methods. So counter returns a dictionary with on some extra methods. I call them benefits, right? Benefits, yeah. Okay, so So right now I can get the most count all at symbol level and get what's happening, right? As we remember Sherlock Holmes, when he did his little dancing man, it's even from 19th century, people already knew about letter frequency, right? So it's been around forever, used in cryptography, right? So we'll do a little preliminary analysis. And again, not very surprisingly, we have a lot of space. We do have a lot of white space, right? And then again, E, I think also, if I remember my Sherlock Holmes correctly, my Conan Doyle, that it was E actually was the most common one, I believe, right? Then we have T, O, A, N, and so on. Interestingly, H, probably because of the, right? And so on, right? Again, I'm not an expert maybe on English linguistics, but still looks reasonable. So that's our counter. And again, why am I doing this? Because I want to get some idea if there's anything funny going on, right? Before I proceed, is this text good enough for proceed at the word level? I start at the basic level. I don't want to go down to byte level, but I'm looking at symbol level. So now, using this, I'll show you how, again, this is most common, right? From dictionary, right? So, counter, right? It's a dictionary, right? So I can convert it directly into a data frame, extra data frame to check it out, see what's going on. All right, let's do that. So I'll pass directly the counter, the dictionary, right? Orientation index and reset index, and this should be just numeric index. And I'll rename the columns, right? Rename the columns, right? And see the first 5 entries, right? So we have the first 5 entries, but they're not ordered, right? I could have used, you can see the count, there's 68,000 commas, there's 310,000 O's, and so on, right? And look at all this, space. Right, so how could we order this, right? We could have, of course, already used this past the most common, but I will show you how to do this in pandas, right? It's easy. You do order by count, right? I enter the by count column, right? Okay, it could be any column, of course. It will depends what kind of ordering. If it's it's going to be lexicographical. If it's going to be a string, text column, or numeric if you have a count. So actually, let me check. Is this actually a real? Is this actually a number? By the way, let's check because sometimes I don't know if you have seen this, but if you sort things, there's a difference between lexicographical sorting and numeric sorting. Like if you're counting sorting 9, 0 string, right, or 9 and 20, right? You store it lexicographically, right? As a string, 9 will be on top. But however, if you sort numerically, if it's numbers, right? Of course, 20 and 9 will be under. So let's check. Did I not symbols? Sorry, I see typo. It's an integer. So yeah, it'll work correctly. So here I pass. I have a data frame, so a table. I'm going to sort the values, and I'm going to pass some. I need a column. I could also, sorting can be done by multiple columns, meaning you have tie breaks. Maybe if you have exact counts, then you can say, okay, if the first column gives you exact, tie break, we go to the second column. We can sort differently. So you can have maybe 5 different columns. Of course, the first one will have priority, right? And then you sort by next if there is tie break. Right, so you can pass a list, right? So ascending false. So this means we'll start from the top. Ascending false means it's descending through, right? And in place. By now you should know this is very common in a pandas library. It's full of in place, out of place flags. What does it mean? You can say if it means in place, this means it will modify this data, right? If you say in place is false, or maybe it's by default, is it false? No, it's true by default, apparently. So if you say in place is false, you can return, it will generally return also the data. You can save a new data frame somewhere else. Maybe, you can save you have maybe you need a different version of something, right? You want to keep the original order. So here I don't care about the order, so I'm going to use in place, right? Why waste memory, right? So let's take a look. Let's look at our top 25 list. And again, as expected, E is top, but of course space is the real winner, right? W is pretty high, right? F, point, comma, G, right? Looks okay, right? So top 25. Let's do a little plotting. So let's go already into a little bit of visualization. When you're exploring your data, it might be helpful and then also not only fun to do some little plotting. So by default, Pandas using matplotlib library. You can also change to Plotly or some other library. For now, we'll use matplotlib. On basically, I'll do a bar chart. On X will be, of course, the symbol column. Y will be the count column. And I can adjust the size, I can have titles and all kind of good things. But for now, we just want to get some idea what's happening, right? And let's plot it. And probably might have used the log scale, probably, because we have this huge dominating space, right? It's kind of ruining the rest of the story. But we can see the top 50, right? In this case, of course, the capital letters are less frequent. What's the most frequent capital letter? Looks like A, right? Yeah, looks like A. Is that really? Does it beat any of the small letters? No, it doesn't beat A. So A, M, S. But yeah, it beats, or X. Does it beat X? Yeah, it looks like it beats X. Yeah. What was the story? A little side note about X and what's the name? Descartes, right? The famous. You know the story about why he came up with X. No, in 17th century, in algebra. René, how do I pronounce it? Yes, Descartes in Latvian, right? So what's the story? Why is he using X? Why did he use X? It's actually because his typesetter, his printer, he told him to use X. Why? Because of this graph. Because it was not used that much. So he said, use X because nobody else is using it, right? He says, yeah, in French, apparently in France, they're not using too much X, right? So yeah, use that, okay. We have too many letters X, right? Why not? Right, that's a story at least. So, okay, right, so yeah, we have a distribution. Again, it gives us some idea. It doesn't look too bad. It looks pretty normal, actually, right? Again, of course, we have to deal with this space. We'll have to probably still have some extra space. Maybe we didn't clean enough, right? So let's look at also, I should probably see how many symbols I have. I didn't check, actually, how many symbols I have. How many symbols do I have? Yeah, length, of course, right? Or we could also use shape. Shape would also work. Shape would work as well, right? Div symbols. Shape would work. Yeah, shape as well. So shape gives you, so only 100. Of course, 100 is like, it's a little scary looking number. Why? Because it's so round, right? This looks like a coincidence. This is really 100. So it's like a question. Did they do anything? Whoever did this preparation, did they do some sort of extra maybe culling or cleaning of data beforehand to end up with only 100 symbols? It's a little scary, right? So, but let's look at tail, right? Again, I'm always suspicious when I see round numbers, right? So let's look at tail. And yeah, it looks okay. It looks like all these weird symbols. A big X is not very popular. And we have these weird symbols, whatever, like this OA, OE. How do you pronounce it? I don't know. There's looks like something like, I don't know. They use this in, looks like a little cross, I guess, right? Right, we have some pipe symbol. We have some X. We have something this, right? Some of those, I know they use, the Old English use some of these, right? Some of these I'm not sure. But the thing is, they're not very frequent, right? Z is like a normal symbol. So for most part, this looks like a really nice data set. Of course, my assumption is, of course, this came from Clarin. So they did this university, I think it's University of Sheffield. They've done some cleaning themselves. So we're in good shape. But let's do some more extra checking, right? So let's look at our tail. We can plot a tail. Yeah, so we can see what's happening. Again, it's a long tail, but again, it's only 100 numbers, like 100 issues. So, oh yeah, here's 100. Yeah, so now let's make a new column for our unique symbols. We have a count column, we have a symbol column. Let's do a Unicode column, right? So again, I'm going to be using apply function quite a bit. It's much faster than looping through. It kind of loops for you. You say, okay, so this recipe in pandas, so I supply column name. And basically it says, take the symbol column, go through all rows, and this Unicode value will be this odd, use this odd function on every single character. Of course, it's possible, if you look at how odd is done, for one character string, if this symbol column had like multiple characters, it's possible we would end up with an error. It's possible, right? But in this case, it is really full of one character strings, so it will work. Let's check it out, right? It worked fine. Again, so let's check, do we have any special characters, some weird things, right? So weird things, anything over 127. Because the way UTF-8 encoding works is that in English, all the standard letters for a long time were under ASCII encoding, right? American standard for something, right? ASCII encoding. All right, we have ASCII encoding, and this is from 1930s, even before computers, right? Table, right? This is what we basically is underneath everywhere. Do we have a nice table? Right? But basically, all of these characters are not going to cause you any problems. Oh, come on, I don't want cookies. Okay, yeah, so basically all of these characters. So this means all letters up to tilde, underscore. All of these are handled. They will encode exactly the same way in UTF-8 encoding, right? Which we are using now on old ASCII table as well. So it's kind of tricky. So what happens is basically anything after 127, it might really depend on the type of encoding used. Right? So we'll see if we need anything special needed for those symbols. So let's check out which ones do we have. So this shows you an example how to apply a filter over pandas data frame and save results. And actually a slice. So one thing is that you mentioned, so I'm applying a filter. I'm saying this is going to return a truth or false table, a series of truth or false statements for each row, right? Whether Unicode column for particular row is true. Let me show you maybe if you want to see this. So this is pandas specific, very, very common. So like this is going to give you a truth table basically. See, false, 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 true, it ends up with true. These really rare ones at the end are true, right? The Unicode is over 127, right? So what we do is we basically give it for each entry, we give a true, false value, basically get. And that's how we can filter, right? So you can do your own filtering. It does not have to return, your filters don't have to come from the data frame itself. You can apply filters from some other external source, even from other data frame. You just need the same number. It has to match. In this case, you need 100, right? You need 100 values. It doesn't matter how they came. They just need to be true, false values, Booleans. Okay. So now we will have, how many we'll have? We have 13 over 127. Let's see them. There's only 13. Let's check them out. So these are the ones. What's called deficit, right? What's called, right? In English, how do you call it? How do you call this? Hyphen? There's three of them. Yeah, so dash, yeah, there's dash. This is not dash. This is hyphen, I guess, and there's one more. There's three of them, right? The third one always gives me trouble, right? Small one. It's a small one. Hyphen is a small one. So it's not so there's defis in Latvian. They call defis, and there's one more, right? And again, older texts have this quite a bit actually. Even Latvian ones. I've encountered this quite a bit working with older texts, right? So. So it has a weird Unicode 812, right? And of course, that's kind of natural. There's a pound symbol. And again, Unicode is 163. It's interesting. It sits, they gave it a first byte, but it's, of course, depending, in old days, you were not guaranteed to get a pound 163. Maybe if you're using Latvian, you get a, I don't know, a euro or dollar sign somewhere there, right? So this is an interesting symbol again. We could, of course, go to Unicode.org, right? Unicode.org, right? And check them out, right? Maybe, yeah, that's what I'm thinking too, right? That's kind of, you have these in obituaries, but this is not obituary. These are trial accounts. So maybe some juror, I don't know, maybe there's obituary in the middle of somewhere, or maybe it's part of that. This would be very interesting actually to check out what's happening here. But we don't have to, well, actually we have many. No, we have 16. Okay, not too many. So we see, really, there are very few of these, except of course this long one, which is basically, they use this one, at least in Latvian, they use it to start some text fragments for like a speech, usually. Right, so this most likely we are fine. And we have some weird things too, like only a few of them, these are really interesting. Like, and of course we have these multiple, we have one occasion we have three dots, right? But it's one character, it's not 3 dots, it's 1 character. Okay, all right, so what are we going to do? We can plot, of course, it's again just the same thing, nothing. But again, so but we don't have too many of them. So yes, this would be, of course, beyond the scope of this exploration. Be very interesting to see what they mean. So maybe looking deeper into these extra symbols. So my wild guess is, again, as not a specialist in this Old English, they're probably part of some English alphabet, something that they used. Maybe, like I said, the cross, maybe for deceased, right? Again. We could have we could remove them, we could leave them as is, right? In general, they're probably going to mess up our standard text exploration tools because they're just not used to these. So, main thing, so now, also, yes, it is possible that they were basically artifacts of OCR process. Because, of course, they had to use optical character recognition, and maybe there are just some mistakes. Those who work in library know how often OCR, old texts processed with OCR, there are mistakes. So it's possible that some of the weird ones are there. So, but there are not too many. So in either way, we could just remove them or leave them in. But for now, I want to remove the all extra white space. So I'll show you a little trick how to remove all extra white space completely. So meaning idea this, anything that counts as white space, 1 white space, 2 white space, 3 or 500 in a row, that includes what? New lines, tabs, some spaces, of course, right, and some other ones. Full list of, let's see if you can find a full list of full list of white space characters. Is file format? Is that no? I want to see in Python. But actually, yeah, let's see string white space. What does Python consider white space? Yeah, and I believe it's somewhere here. Let's see. White space, yeah. What is white space? Okay, space, tab, line feed, return, form feed, and vertical tab. I've never seen vertical tab in use. What does vertical tab do? I don't know, right? Maybe, yeah, so form feed actually, again, it comes from, again, these different operating systems. Sometimes they use different ways of making a new line. Again, how it was in old typewriters, right? Remington, right? You had 2 operations. You say, I think it was like a form feed, and you have basically 2 operations. That's where it comes from originally, right? And you do you actually have a physical typewriter, right? So that's all white space. So this regular expression, again, it's a great site. I recommend this, or there's some other sites, right? You can practice your regular expressions for cleaning. And here you can see this white space. I think it's actually part of the standard here. And let me see. Any non-white space character and any white space character, right? So here we are saying any white space character 1 or more times is to be replaced by a single regular white space. That's a rule, right? So it will catch. So if it's a single white space, it will be replaced with the same thing, right? If it's 2 or 3 or 5, it will replace with the 1. There's also this R, right? What's the R? That stands for raw string. Why are we using it here? Because regular expressions is a very heavy user of escape of these special backslashes, right? And the problem is if I was not using this, what do I have to do? If I want to skip this, then this is not going to work. You see, it's all a mistake. I have to do this, right? I have to escape what's going to be escaping again, right? So it's like double work, right? Because why? Because in Python, for regular strings, we use backslash also to escape special characters, right? So that's why I'm using R to save on typing. In this case, I'm not really saving much space, but you have a longer regular expressions, right? So again, so basically this function, you give it any text, and it'll give you a text which is cleaned. Okay, let's test it. Let's test it. Well, let's test it. Let's test it. On hello world, right? And I want to print. Oh, well, actually, it's going to show it, right? So, yeah, it's cleaned nicely. Hello world, and again tab, new line, on the Baltic Humanities. Baltic Humanities. Oh, wow, it knows about Humanities summer school. Yes, okay. But I will have some extra space and some new lines and some extras. I don't know how to vertical tab. I don't know how to spell it. Okay, how to write it. Okay, so now, yeah, probably V. But now you see it's nice and clean, right? There's no new lines, no nothing. And of course, again, in this case, I'm using the notebook ability. I'm not using print because, of course, notebooks always you let you print. Basically, it returns a representation of whatever you did for a cell, the last entry, right? It's like a free print. It's not exactly the same thing as print. It's actually a representation of the string. It's a little bit slightly different, but it's very useful, right? Because it saves you time, right? We're all lazy. That's good. It's a good thing. So, okay. So now we know how it works. So now, of course, as I'll be showing it over and over, using apply, right? So one of the things mistakes with pandas you can do is to try to loop over something. You don't want to. You usually want to say do something, right? So in this case, I take a text function. I have text column. Text column. I'm going to apply this replace whitespace function. This one I define a function which takes text, and it just so happens my text column has text. Okay, great. Of course, these names don't have to match exactly. It could be txt or something, just to show you, I'll make it txt, right? Not Control Z, txt, right? So I'm using, by the way, those who are using Visual Studio Code, a little trick, right? If I do this, I can press Control Delete, Control D, and I have multiple cursors, right? I can write two things at once, right? So if I have like a text fragment, I can edit like 10 places at once. It's useful if you need to replace something in a local section, because of course it has global replace, but this is for local replace, very handy. So let me run this again. This is just pure, just show you that they don't have to match, right? This is just a column name. Another thing is, I don't know if you have touched on a column names in pandas, right? So there are two ways of accessing columns, right? We have the full syntax, right? This, right? And we have this syntax, right? The lazy syntax. Okay, so there are some books that say you should never use this syntax, right? But it's just so handy. So what's the problem with this syntax, right? Because the column name cannot interfere with the methods, right? But because dot, usually we use some methods, right? So if you have like a string or find or something column, right? It's not going to work very well. So this is the full. This will work always. Also, this is also if you have a name of the column in a variable. So this you need to use this syntax then. If your column name is stored here as a variable, right? You just instead of a string, you have actually a variable holding the string, right? Then you can supply it like this. So, but this is very handy if you have a nice clean column name, and also, of course, And as a requirement, the column name should be only without any spaces, right? No white spaces. Again, those white spaces, right? Messing things up for us. Okay, right. So now we have a column, and we're going to use the apply function, invoke function on values of series. So this is basically a single column is actually so-called series. Data frame is a collection of series, basically, right? Series is a little bit more basic than a data frame, right? And actually what series is, basically it's a NumPy array, actually, with the values and some extra methods, really, underneath, for most part. So, okay, so let's run it. So question, I say all this warning, and of course, this is just to see how long it takes. It's not necessary because, of course, Jupyter notebooks, they also provide some shows the time of, so you can see this also here, right? 0.3 seconds. Looks like about, 0.3 seconds, yeah, so it matches, right? Almost 0.4 seconds. So now, let's see our unique symbols again, right? So since I did this once and again, so what I will do is I'll make a function. Usually, if I do something often enough, I will make a function for doing this next time, right? So I don't have to repeat myself, right? Because, so I'll make a function, I give a data frame, a column name, again. So you notice how here I can't use text, right? Because I'm going to be giving it a text. This is going to be probably called text, right? But I can't say, I can't use a short syntax. I have to use a full syntax here, right? And I get the full text, I make a counter, and I make a new data frame. Also, I reset the index. So let's take a look. Oh, I could have added also sorting, but sorting I'm doing it afterwards. Let's take a look. Yeah, and we have, I think we removed about 400,000 white space. That's quite an improvement. Right, it was not doing any good to us. I mean, I'm thinking, where could you use this extra white space? I mean, of course, you need it in Python, right? We need them here, right? That's actually language models sometimes struggle with Python because Python is dependent on white space in certain things. But for most part, for historic text, I think the extra white space is not going to be very helpful for most part, right? Of course, for paragraphs, maybe somewhere you have some separation of paragraphs. This information you would not want to replace, right? Again, so again, we are always, there are always trade-offs. We are losing some things and we are gaining some things as well. So, okay, let's try to save it again, and it's going to get bigger, right? So, what do we have? This is what I'm going to say. Temp file. What's my df? This is a big one. So let me do. What do I have actually in df? Why am I saving it here? I think it's because I was afraid of. Okay, but there's actually not much point saving it. Not at the moment, right? But I could, right? I could. Why? Because I saved the. I actually it makes sense because I removed all the white space. Oh yeah, sure. Why not? So let me save it. Yeah. Okay, now we are at the important point. We have our raw text, we removed our white space, but how about the one of the basic steps is removal of punctuation. So generally, punctuation is not important, right? But it can cause problems with when you're creating tokens. Also, they might be at the end of the words, not useful. Sometimes, of course, if you're analyzing how many people are using exclams in their text, it might be useful. Also, if you're going to analyze on a sentence level, you might need the punctuation, of course, to keep the separators for the sentences, right? But for now, for this workshop, we... Yes, sure.
For instance, data in Latvia and abbreviations and a lot of other stuff.
Yes, of course. Yes, yes, it's not. It's like I said. So again, if you're doing this, you need to state that you're doing this because you can't just kind of skip over there, and you might end up somewhere. You might have to go back to this step. So this is kind of important step. I'm saying is after this, you might want to keep the original here around because you might need this. Basically, because there might think, okay, I could really use the punctuation here, right? So I'm going to show you how to remove it, but it is possible. You might need it also, yeah. There are different tasks. There are a couple. So, Yes. Yes, yes, yes. Again, it's a whole thing. I personally also usually I keep the punctuation as long as possible, and maybe I keep some of punctuation, forever, basically, right? So, but I'll show you how to remove it. But it's also can apply to other things, how other ways of cleaning things. So the way to there are other ways of doing, but the proper way to do it is use something called a make trans. We make a translation table. We basically, and this can be applied not only for cleaning, removing things completely, to also making transformations. Let's say you have some old symbol, you want to remove, change it to something else. So what you do is you build a list or a string of whatever you want to replace, all right? And then you do this. You have the you have what you want replaced one by one. It's going to be a string, and in this case, you want all of those replaced by empty space. Instead of this from keys, right? Instead of this could have been also different values also. But in this case, all of these we want to replace by nothing. But we could maybe replace them by, I don't know, triple X, I don't know, right? Sometimes when you're doing translations, you might want a temporary or so-called sentinel value, some weird character which is not used, say, in Latvian. And it's sort of like you do a translation, and then afterwards you use this weird character to translate back to normal, like a sort of placeholder. But in this case, we are going to replace all the characters. In this case, it's going to be punctuation. And also, it's not only going to be punctuation, right? I could show you the punctuation. So basic punctuation. This is what the Python thinks is punctuation. String, sorry, not string, yeah. String. This is basically a constant string, right? So that's, all these symbols. That's what it's gonna want to remove. Again, like I said, there are good reasons for leaving some of these in, for sure, right? But we also want to add some extra symbols. And remember, we had those over 127 symbols, right? The character, right? So we can add those. So what I'm using, a little trick. So this is one string. This is another string because I'm taking empty string, joining all individual symbols in the next string. So this, right, here, right, I'll show you. Maybe here, I'll do a comma. Yeah. Right, so can you see this? Yeah, you see here, right? So I'm going to add this. And so these are two strings, right? These two strings, I'm going to add them together. Again, if there's something maybe... I think there are no matches. I think this is long, this is a short one, dash, right? There's underscore, snake, right? And also this hyphen, I guess. Okay, and all these weird English ones. Okay, so this way, we are going to build a translation table. Basically, it's just a dictionary. So basically, you could, translation table, it's basically a dictionary, integer to string, right? So integer values, right? And also, so this is all these Unicode values, right? Yep, yeah. On 33 exclam, if you look at ASCII table, exclam should be probably, it is exclam. 33 is indeed exclam, if you can see it here, right? Yeah, and so on, right? So that matches perfectly. So you could be, if you didn't, so this make trans is strictly not necessary, right? We could build this table ourselves, right? It's just a dictionary, basically, right? It just needs Unicode point, Unicode code, what you want replaced, and what the new value. You could enter something else here, right? Something new value. So now we're going to apply. First of all, since I'm interested what's going to happen, I am going to make a new column called dirty length, which is all the lengths before the cleaning. I just want to see what's happening, how much, right? So I have all the text, right? I'm also going to sum up. So 5,200,000 something characters, right? Symbols or glyphs. So, and I have, okay, so translate text. So yeah, so basically the way it works is this. You have a string, you have a translate method, very handy, right? And you supply the dictionary of translations. So you could do this with a loop, right? But this Python does it for you, right? So translate text, and I am going to supply this function. In this case, it's just a really thin wrapper. I'm again use the apply, right? So a text, so I'm going to lose some text here, right? Because I'm overwriting. If I want to keep original, what do? I will have maybe a new column. I have text new or text clean or something like that. I could make a new column, right? So translate text on. It should be pretty fast. It should be less than a second. This is different computer. Yeah, it's about 3.3 seconds, right? Yeah, 0.3 seconds. A little bit slower, but still fast enough, right? And through all the 16,000 something entries, right? So clean. And now let's do the clean text. Let's see the difference, right? Again, I use apply, but in this case, I don't have to make my own. I apply a length function. So I say, make a new column from the length of whatever is in text column, right? So I'll print this one. Maybe I'll move this here again since. Right, so you see I have dirty length and clean length. I made these two new columns just to see what's happening, to see some process. Again, I could have also kept the originals, right? But right now you have to keep in mind that this text is already quite a bit cleaner. Again, of course, losing some information at that process. Okay, so 506, and we can check, since if you're too lazy to do the math, 220,000 characters were removed. All right. Just to see, you can see that you can track the change using these two columns, So again, we can save it again. Of course, I will overwrite, but of course, I could also, again, I recommend doing no index because for CSV. And we get to the tokenization step, right? And normalization. Again, and this is another step where you're going to lose some information, especially with named entities. But for machine learning algorithms, generally so John with J, right? But there's in Latvian, of course, last names, right? Of course, they might have some important information. But so normalization is typically lowercase, right? So so you could skip this step, of course, if you think the names might be important, right? Or you could do a selective normalization. Maybe you have some specific cases which you don't want to lower. This is like a so to say really rough approach. It just says text is whatever string is in a text column, and I apply lower function, right? This is very fast of operation, and basically you will not have any capitals, right? So again, I know it feels like, so I'm losing information, right? But again, if you're doing some topic modeling, things like that, you have to, it's a trade-off basically. If you have too many things which were only a single letter with single letter difference, like for example, the with a capital T or with a lowercase t, right? They are the same really, right? But of course, John, again, there shouldn't be any difference, but there's not going to be any John with a lowercase j, right? The question is now in Latvian, I'm sure we can find plenty of counter examples, I don't know, Arais, or Bērziņš, right? Well, they could have a, capital. Yes.
A nice example is I, S in Latvia,
Yeah.
which is also abbreviation of European Union, ES.
Yes.
And when you do machine translation,
Yes.
you have very nice.
So this is something where you would want to have these custom exclusions, right? Basically, when you're cleaning, you want to say, okay, is this actually okay to, or do we leave it? That would be the best way of doing it. You would make up your own table of what you want to keep or what you don't want to lowercase. Right. So because again, it's a trade-off. So, but again, this is really if you just lowercase everything, right? And let's check. Let's do a little check on. It's basically I'm gonna do if there any uppercase. There's a function. Check uppercase text, right? And this function returns true if there's anything in a list is true, right? So what I'm saying is I give it some text. It will go through text one by one and check if all the characters are actually any. Just one is enough to win this game, so to say, right? if they're all false, it will be false. If there's just at least one, right? This is in, how should I say, in mathematical logic, universal quantor, I believe, right? And there's also, this is existential quantor, right? And there's another one is, there's all, right? You can also have all in Python for logic, right? There's also, there is also all. So this just requires just one, all requires that all of them are true. Okay, and we again use our friend apply, and this creates a new series, but I'm not going to save it. I don't care about saving it. I'm just going to check the sum, right? And not surprisingly, I have 0, right? So there are no uppercase characters whatsoever. Again, keep in mind, right, that not always upper case, you might want to keep some of it, right? So, 420. So, tokenization, next step. Again, so what's a token? Actually, there are different ways of thinking of tokens. A token could be a sentence, could be a word, could be actually even a document, could be a letter, right? Could be a symbol, could be a half word, actually, right? So here, for most part, the basic example we'll talk about words, but since we'll be working at word tokenization level, so what do? We're going to split on white space, right? So because again, we did all this work, so we have nice single space, right? But in fact, we could have even skipped this because, I mean, we didn't have to clean up too much because the Python split, as I mentioned, right? It's actually not even a, I mean, we can make this, right now it's just a simple wrapper, right? So right now, by default, the split, it works on any white space. So you have 5 white spaces, right? Between words, it will just treat as one white space, right? So we technically don't need it. We could split on a single white space because we did all this work already, right? So let's split it. And actually, again, of course, this is just a simple wrapper, but but before we do it, we could check, do we have any white space left? We shouldn't, right? So again, we'll make another helper function. It gives you some text, and it returns, does the regular expression search for 2 or more white space, right? So this, if this is not none, right? So it will give true if there's at least 2 or more white spaces. Let's see. Probably it should be 0 again, right? Should be 0. No. Or let's check. Do I still have not clean? I have not cleaned it yet. How did I forget? Or maybe I loaded something. Yeah, I still have some white space left, actually. I thought I cleaned it. Oh yeah, it's actually no. Yeah. Maybe. But yeah, with the joins, that's why, exactly. So we have to go back again. So, but, so we can remove it if you want, right? So again, remove, resub. So we supply 2 or more white space. Again, this means any white space, tab and so forth. On with one single one, on text, right? That's we're gonna supply, right? On we can again use it apply, right? Very simple. We figure out what to do. So basically, you need to provide for apply to work. You need to supply a function which takes the element and gets something out, right? It doesn't have to be text. It could be theoretically numbers. It also would work, right? But again, so single entry, something comes in, something comes out, and you use it on a text column in this case. It should be now that there's no white space left. And indeed, it's almost instant. It's very quick. These operations are very quick. Even on large, again, these cleaning operations are very quick. So it's 0. We have no multiple white space, right? So now split again. I think I already did this. I think I have now a duplicate function. Didn't have to do this over again. So split, and yeah, split. The question is, could we do it without this? Let's try this. Since this is without this function, can we could do a lambda function. By the way, yeah, this is same thing. Since it's so simple, I'll show you. This will work, right? But we could do it also with words. Okay, since this is we can experiment. Since this is words, I'm not overwriting text, right? I'm creating a new column called words, right? with these tokens. So I'll show you, okay, we'll do this first. Right, so words, pretty quick, 0, 0, 0, pretty quick, and let's just check what we have. So we see all nice little, can I go, no, can I go here, come on, where's my scroll, oh no, actually, they're not scroll here, so off, you see, this is actually like a list, looks like a list, right, it's actually an object, but it's actually a list underneath, right, and you see it nicely split everything, right. And again, of course, you see it's all lowercase, right? So cook, right? You see another example, right? Cook obviously might have some issues because it's a last name in this case, but also if something to do with cooking. So this might, again, maybe might have been one of those exclusions. Okay, but now I'll show you the same result if I didn't want to do this. Can I do this short? Because this is such a short function, right? And there's no extra, there's nothing fancy, right? Could I have do it immediately here? So I will do this. I'll do this, I could do the above, but with lambda, yeah, so lambda function, so something like this, yeah. So it's the same thing, so x or t or anything else, right? So what's a lambda function? Who can tell me what lambda function is? What's a lambda function? It's a very simple, a simple explanation. It's basically a function with no name. There's no name, right? It's people scared of lambda functions. It's like there's all kinds of fancy things, but basically it means apply needs a function, right? We could supply a function, and this particular function, the way it works, it needs a function which takes one input, right, and one output, right? Nothing fancy. No triple outputs. Well, triple outputs work, but no multiple inputs, right? So I could provide it here, or I could write it on a spot, right? So for simple cases as this, and if you're not going to use this over again, right, you can do it on a spot, right? So that's all it is, really. I mean, it just sometimes gets too bothersome to write all these custom functions for everything you're going to be using apply. And apply is not the only one. For sort also, remember sort is apply the function for the key also. In programming in general, there are many cases where you have a method or function where it needs a parameter, another function, right? So it's saying the way this apply works, right, it needs a function, you see? Function which returns something, right? Scalar, sequence, something. It doesn't know what it needs, right? So I write it one. So this is basically a way of writing a function. X comes in, that's text, right? I could write text, or txt, right? That also doesn't really matter, right? This doesn't matter, doesn't change the, right? Or you call element, right? Because we talk about each single cell. So because we're going to use it for apply, right? Which is going to be a single cell, right? And now it should be exactly the same. Let's check. It should be exactly the same because I'm going to overwrite. Speed-wise, this should be slightly faster, but roughly the same. And yeah, it's the same thing exactly, right? So now you see how lambda functions are nothing scary. Does it make sense? The lambda function. Yeah? Okay.
This one was a friendly lambda.
Yeah, this is a friendly lambda function. Yes. They can get rid. So here's the thing. If you end up writing a long lambda function, you probably will be much better off writing it separately as a function and then passing it in, right? So I think that's why they get a bad rap, is when people try to be fancy, they think they hot stuff, right? And they write this big lambda function. Maybe it's late at night, I don't know, after the 6th coffee. But then in the morning, you might not remember what you're writing, right? So yeah, because you don't have much room to write comments and things like that, right? And a function, you can take your time, make it nice. Speed-wise, it's not going to make difference, right? So, okay. So we have our data, we have our words. That's really good. Okay, I'm curious about the word count, right? So again, I'm going to use my friend apply, len, right? So here I supply. I don't even need to write a lambda function. I supply a already existing function in Python, right? As we know, len takes something, right? I can do it like directly, right? I don't need, it's like I don't need my own function, I don't need the lambda function, I just supply the one built in. So I have a word count, supply len. Now let's try it. And we should have word length. No, sorry, word count, word count. Are you with me so far? Everything collab works, right? Okay, great. I want to get to our, we're doing okay. Tokenization, normalization, stop words, lemmatization, okay, we're almost done. Okay, great. So we have our word count, 129. So we can see basically how many of these clean words are there, right? And now stop words. Now that's another thing. What's a stop word? Basically, which is a word which you don't need, basically. Again, so like we had bad characters, we have words which you don't need. And this is one of the cases where you will actually might have some issues with the collab. We'll see if you have issues. So basically, we want to load. Generally, you don't want to make, well, you can make your own stop word list, but there are stop word lists around. We'll be using one from Spacey, right? Also, from the NLP object, right? Language model, English one, and we will get the default stop words, right? So stop words usually are just basically shared. Somebody just compiles them. Things which are generally not important. But the thing is, again, there's some like I, S, right? Generally, again, if you not oftentimes important for many concepts, but sometimes if you're exploring, like, I don't know, questions of identity or something, they might be important, again. So you have to check what you are actually deleting, again, right? So let's check how you do it from Spacey. And this is where I think on Colab, you might have problems. Why? Because as I mentioned, this is a good way of checking. I'll run everything in a Colab. Okay, reconnect, let's do it. So what I'll do is I will run all, and it should present an error at this point, right? So this should be the only error. You see, it made all these graphs, did everything. It should stop. Let's take a look. Yes, and that's why I made this error, so we can do this. So return tokenization. We did all of that on 0 seconds. It's all good. And now we should have an error. Transportation, stop word. Okay. Oh, actually, do I still have it? Oh, everything worked. Oh, Colab has it, actually. Oh, yeah. So actually, it looks like because it's English. Okay. So if locally, it might not work. So what do? Right. If it was not working, you do this command. So in a local installation, you will have to do in a terminal. Right here, and of course you need to activate your local, but this actually doesn't really matter. So when activate scripts, activate PS1, it's not been picked up. Okay, and you would do this command, Control V, right? You would do this. So Python M Spacey module, you do a download, and here you download the small English core, right? It looks like the Colab, so you didn't have any errors, right, on Colab? So these are but you get locally. So yeah, you basically what you do is you enter this command terminal, right? Python M Spacey, but do it in an environment, right? Okay, you download it and then run the cell again. So basically what it does, it goes to the library and it downloads the correct model for the English, right? So we have some time a little bit. So Spacey is a great library. Unfortunately, it doesn't have very good Latvian support. But basically, because of course it's open source library, it doesn't have too many Latvian contributors. I checked, at least last I checked, there's some good Lithuanian libraries. Anyone from Lithuania here? Yeah, so you're in better shape for Spacey, right? You can use Spacey for your Lithuanian needs. So Latvians really need basically just need the grant or something to work on this. So. Excellent. This will be great news. Because it's again, instead of using like some sort of close, lives or knowledge will be living somewhere else. It lives in this big happy family. So we'll get the English ones, right? Because if you go Spacey, right? If you check the Latvia support, right? Or colleague is talking about NLTK. So what's the difference between Spacey and NLTK? Spacey is more for actually getting things done. NLTK is for initial research. It's not really good for any production, right? So let me see it says 73 languages, but like I said, I don't know if I can show you. It's really, like I said, the language, it will tell you. The Latvian doesn't have much, last I checked, right? Yeah, it will tell you. Yeah, so doesn't have tagger, doesn't have morpholizer, right? All the good stuff. Right, okay, so, but here I'm just using spacey for the stop words, because at least, yeah, so you see would, when, do, move, becoming, front, or, again, something like this, but this actually shouldn't even apply because we already removed all these things, right? So, let's see about others, right? There's another place, scikit-learn, which is another machine learning library. It also comes with stop words, right? So it comes with the English stop words again. And it comes with an interesting, so this was what? This is a set, I believe, right? Yeah, I think, and this is actually a frozen set. But actually, so you can change it, but it might be interesting, just a little side, compare them, right? So let's see, let's do a set operation, right? We have a Venn diagram of two of these sets of stop words. Let's combine them, let's do a what we call Latvian šķēlums, intersection, right? So we'll combine them. Both will be sets, and I will end up with common words which are in both. So I'm saying, okay, let's use the stop words only from which are in both of these sets. I've seen even larger, like stop words of 700, even larger lists again. So here, we have 291, so there were like 326, so some of them we removed. Again, we could have just taken one, right? And of course also, possibly, for example, it's removing, I don't personally like too much these number ones, right? Sometimes they're actually useful, these number ones, right, for the analysis, again. So now, we have stop words, and we'll make a function. And maybe common stop words, what I'll do is, yeah, it's like this. So it's a function which takes words and goes and returns a new list. So a function takes a list and returns a list using list comprehension. But an important point here I want to touch on is that this part here, right, this filter. Let's say we have a big list of something, common stop word, maybe like, 5,000. If this was a list, this would be a quadratic operation because we have to go through all the words, right? Well, actually, or maybe even cubic, because if you have a row of many rows of list of words, and for each of those we have to go check word by word and go through these stop words. So it's very important here in this stop. This will save you a lot of time. If this common stop word, it's a set. Why set? Because set, the lookup, this operation. This part here is very quick. It's like, so in computer science terms, it's all one operation. So this means it doesn't waste time in this step, right? So you're already wasting a time. I mean, you're taking all this time going through lists. You don't want to waste extra time checking. You check immediately. Is this word in this set? So set, look up in a set for an existence check, yeah. Yes, if you need to check for their existence a lot, if you expect you have a list of unique values, first of all, you use set to get those unique values, it's first thing, right? And then if you expect to be checking frequently for these values, right, for existence, again, keep this set, use this set, right? It's a very common, I would say, mistake, but it's basically optimization mistake if you use the list here in something like this, because this, if you have a list of million words, right? It will have to go check one by one in a list or tuple, right? If you have a set, it's going to be like this. Why? Because it basically calculates the index. It knows where to go, basically. It's the set structure. Even if you have a huge set, it will be instant. So it's a big difference. Especially if this is a long set, if it's a long list, potentially long list. So you spend some time before making a set, right? Then it will pay off dividends when you're checking, right? So that's something, a little aside for optimization. So let's do this. Apply, and let's see. I think this takes, a second at least. It took a second. Yeah, about a second. No, 0.1 second. 0.1. So now, on cleaning, after stop word cleaning, you see there's a huge difference actually, right? We removed quite a bit of words actually, right? Looks like both of these texts were about halfway done of stop words, right? So again, you would want to really check, see if maybe something's important, right? Again, depending on it, really, the answer is what you should remove, what you should keep. It depends. Really, it depends, right? So we can see how many words did we remove, how many we have left. Yeah, we removed about 500,000 words. So basically, looks like almost half where didn't have any meaningful, well, something to add. Again, it's not really strictly true. They might have something to add. Depends what you want to do. So now we get to almost the final thing we want to do today is lemmatization versus stemming. So what's the question? What's the difference between lemmatization and stemming, right? Stemming is the root form, right? But I will give you an example, right? So stemming, right? Lemma, generally you want lemmas. Why? Because it's the canonical meaning, right? So I'll give you a difference. So in stemming, you might end up with carrying, right, to car, right? Maybe something like this, right? Right. So and again, so you see the problem, potential problem with stemming algorithms, right? It might not be, it might lead to unrelated terms, right? So lemma is a little bit stricter, but generally I like lemmas better, right? So if you can get them, right? So, but of course it needs some more, possibly some morphological analysis, right? It's not just a simple algorithm. Just take, cut, right? With stems, it's I've used some Latvian stemming algorithms, and they not produce very good result. So, but again, we are lucky in this workshop. We're working with English, so things are easier, right? Because of course, declination. I don't know how they say, yeah, Latvian, of course, and of course I know who is, any Finnish people here? Anybody is there? Yes. So how many forms we have in Finnish? 14? Conjugations? Yeah. 16, okay, yes. So that makes things more interesting, right? So, yeah. So in English, we'll use a spacey lemma function. Again, it's well. Again, in English, you have many wide variety of tools to choose from, right? And again, I'll come up with lemmatization, something like this: word lemma for word, and the thing is, it's kind of silly what we're doing here. I don't have time to actually look up deeper into spacey use. So what's happening? NLP to lemmatize. So basically, this when I pass in some text. So I end up with an iterable, basically, right? So I'm going back from words to text using this join, because then I can use word lemma for each letter. So basically, income words, I come up with a big string of text, right? And back come word lemmas, basically, right? So sort of, right? So this is, I think, the slowest thing today. It took me about 45 seconds. Again, I think this is something that possibly you might want to do some, maybe there might be some optimizations, but again, it's never going to be very fast because it's lemmatization, right? When I'm doing Latvian texts, I use special ALAB tools, right, NLP, and it takes actually longer, right? So, and yeah, if you run it, I want to come for fast, it's on call up. It should be about, I estimate around a minute. 1 minute, because the computer was doing it was about twice as fast, roughly. I don't know. Almost 2 minutes. It's finished, right? Okay, great. How about others? Still running. Colab is probably giving you less resource as far as CPU. Yes. So it's okay. So I'm thinking it should be done. It's hours. How long? So I told you look at this minute exactly 90. I was exactly correct, right? This was just minute and a half roughly, right? So now what we have is lemmatization. Of course, here looks like you see here there's a difference. Indict, of course, right? Which is correct, right? But looks like it's mostly in English. It's very, very similar. We could check, right? Let's check the difference. Okay, so this is again extra credit. So we'll import the intertools, this standard library. So we're going to create a list of words. Basically, what we're doing is since each entry in our words column is a list of words, right? But we want a big chain. So we want to extend, basically, right? So instead of doing it by hand, by a loop, so I pass it to this chain, itertools chain, and it will create it from iterable. So it will create one big flat list, right? And of course, what I do is I pass it to set. You'll take all this big list, just get uniques. I want to see how many regular words, what did we lose, basically? I mean, so it was pretty fast, very fast, actually, right? It looks like a big thing going through iterables. This works much better than expected, actually, very fast, right? So I was actually a little surprised how fast it worked, right? Because very optimal. So we basically in English we had about 22,000, 19,000. So it's not exactly Shakespeare, right? But still, 19,000 unique lemmatized words, right? Not counting, of course, the stop words we removed, right? So again, so a language like Russian, any other language, it will be quite different. So now we will want to save it, and there's going to be a problem now, right? We can save it, right? And look at the file size. Actually, you see, it was late, and I was not paying attention. It's actually not 130 megabytes. It's only 13 megabytes, right? So, right, let me divide by million, right? Come on. All right, so in English, in Python, as you know, you can use underscores for numbers, right? Just as cosmetics, right? Because it's just so you can divide the numbers. You can see these when the Python works with numbers, they're ignored. They're put together. So let's do it again. Yeah, 13. Okay. Yeah. All right. So it's actually 13. So it is actually possible to save. But what I was saying is GitHub. If you want to save it, GitHub is a soft limit of 50 megabytes and 100 megabytes hard limit for any files, right? So what's the solution? Is there a way of chunking things? If you want to chunk things in small, take a big file, right? You can chunk it. That's one way of doing it. There are other things such as large file system, which is I generally don't recommend dealing with that. It's a pain, right? So. Or find some other place where to store data instead of, for your large data sets. It's actually a big problem right now because so many people are dealing with large data sets and their code is in GitHub, but they need a data set. And there are different competing solutions how to do this best, right? So, okay, so what I'll show you is, what I generally like to use is a Parquet file, right? I don't think this needs, but let's check. So what I'm gonna do is, I'm going to save this file to Parquet. So Parquet is basically should be much smaller, right? So 4 megabytes, right? Much nicer. So, and also what's important, you are guaranteed the exact data type, right? So again, why is it bigger? Because we added these extra word lists, right? So we have some extra stuff, right? So, right. So again, let's see what we saved. Let's look at one more time before we leave. Let's say what we saved. Def head, right? Or sample, right? Right. So we have 1, 2. Right. Only things that I would have liked is maybe I should not have saved the index. This index column is kind of not needed, right? but otherwise, it's just a number, but otherwise fine, right? So we have our original words. So yeah, if you, maybe I would have liked to keep the original. If you want to do, we still have but we still have some, no, it's still already cleaned enough. Maybe I would have liked to keep the original dirty data still, right? That's one thing that's missing, right? Because we did clean it a little bit, right? It's lowercase all, right? So maybe the original, for those cases where you might need this dirty data with maybe some stop words, maybe some uppercase, something, right? Going back, would be a preferable original text column unprocessed might be a good reference, because of course we can still get it, but it's not here anymore, right?
What's your final game? What you
Okay, so our final game, which is going to be tomorrow, right? We're going to be creating some similar embeddings, right, for these words, right? And try to do maybe some topic modeling, some document similarity, things like that. That's our game in this workshop, basically, right? So to move on to embeddings, to numerical embeddings, that's the next step. So that's what we're going to do tomorrow. First thing, right in the morning, we will take this lemmatized words, right, and try to, because we want to, basically we have our trials and we want to represent them numerically, basically, so we can work with them in some numerical context. So, yeah, so I mentioned, so mention about Latvian stop words. There is one GitHub repo, but it's kind of funny. This is was made like 7 years ago, and this person did it. I don't think they're Latvian, right? So I don't know where they took it, basically, right? So yeah, that's the only one I've seen it. It's like 160 stop words, right? What else? Right. So yeah, we had some discussion already about how do you deal with words that have multiple lemmas, by the way, right? That's a problem. You might have a word that can represent different meanings, right? So again, your lemmatizer should be pretty smart, actually. The best lemmatizers will be able to take the context, right? It'll go through and create lemmas. Again, so the question might be, why do they want to create lemmas? Because, again, for most analysis tasks, the form, right, the conjugation or declination in Latvian or Finnish, right, it should not be that important. It's more important. We don't want to end up with a sparse, everything only occurring once. You have this curse of dimensionality. Basically, when you have everything occurring once, you can't do any analysis basically on it, right? Everything occurs every few times, so you need some way of combining things. Okay, so tomorrow we do embeddings and we will do some topic analysis, meaning topic modeling. We will try to put these documents, these trials, into some boxes, basically, right? A classification task, right? So I will see about that. So any more questions today? Were you able to follow? Yeah? Everyone in back? Yes? So I know the technical issues with local installation, right? This is something you should work towards, right? But for now, call up worked for everyone, right? And locally, how many people were able to run this locally today? Yeah, more or less. Good. So good. All right. So thank you, everyone. So I'll see you tomorrow, same time, right? 11?